For most of human history, survival did not depend on strength alone. It depended on noticing something small, quiet, and easily missed, a faint change in the air, a subtle shift in sound, the uneasy feeling that something nearby was not quite right. For thousands of generations, people who sensed these small signals often survived longer than those who ignored them. Over time, the human brain became deeply tuned to the surrounding world. Yet many researchers who study human perception and behavior now suggest that modern environments may have weakened some of these old sensitivities. In a world filled with artificial light, constant noise, and protective shelter, some ancient human abilities may no longer be used as often as they once were. And when abilities are rarely used, they sometimes fade across generations. This raises a quiet question about our own species. If early humans relied on subtle awareness of their environment to survive, why do only a small number of people today seem unusually sensitive to those signals? Why only 1% of humans still have this ancient ability? Long before cities, long before electricity, and long before walls separated humans from the outside world, people lived inside a landscape that constantly spoke in quiet signals. The ground carried small vibrations when animals moved across it. The wind carried faint changes in smell. Leaves shifted in ways that sometimes meant nothing, and sometimes meant that something alive was moving through the dark. In that world, survival often depended on noticing details that were easy to miss. A distant crack of a branch might be only the wind, but at other times it might be the slow step of a predator moving through dry wood. The difference between those two possibilities was not always obvious. Early humans could not rely on bright light or protective buildings to tell them what was safe. They lived mostly outdoors, often near the edges of forests, grasslands, rivers, and rocky ground. These places were rich with life, and life always produced signals. Small sounds, subtle shadows, and faint patterns in movement formed a kind of language in the environment. Anthropologists studying traditional hunting societies have often described how experienced hunters can read these signals with remarkable attention. A slight disturbance in tall grass may reveal where an animal passed only moments earlier. A pattern of bird calls may suddenly stop when something larger approaches. These observations do not require special tools or technology. They depend on patient attention to the environment and on senses that are tuned to notice small changes. For most of human history, these abilities were not unusual skills. They were part of everyday survival. Humans evolved in environments where awareness of surroundings mattered constantly. Fossil evidence and archaeological sites show that early members of our species often lived in places shared with large predators. Lions, hyenas, and other carnivores occupied many of the same regions where early humans hunted and gathered food. In such environments, ignoring the small signs of movement or sound could carry serious consequences. Over many generations, the human nervous system became capable of responding quickly to changes in the environment. Modern neuroscience shows that the human brain is especially sensitive to sudden shifts in sound or motion. Even a very quiet noise can activate areas of the brain responsible for attention and awareness. This response happens extremely quickly, often before a person consciously decides to pay attention. It is part of a system that evolved to keep humans alert to potential danger. When a twig snaps unexpectedly behind someone walking through a forest, the body often reacts before the mind fully understands what happened. Muscles tighten slightly, the heart may beat faster, the head turns toward the sound. These reactions are not deliberate decisions. They are automatic responses built into the nervous system. Scientists sometimes describe this as part of the brain's early warning network, a set of processes that detect sudden changes in the environment. While modern people often experience these reactions in small ways, such as when hearing an unexpected noise at night, the system itself has very deep evolutionary roots. For tens of thousands of years, human survival depended on noticing small environmental signals earlier rather than later. Yet the ancient world in which this sensitivity developed was very different from the environments most people live in today. Early humans slept near fires, in temporary shelters, or under the open sky. Darkness was not removed by electric light. Sound was not drowned out by engines, machines, or constant urban noise. The environment was quieter, but it was also more uncertain. In that setting, the ability to notice subtle signals from the surrounding world was not an unusual trait possessed by a few individuals. It was a normal part of being human. But if that ability once belonged to nearly everyone, a quiet question begins to emerge when we compare the past with the present. In a modern world filled with artificial light, insulated buildings, and constant background noise, are humans still listening to the same signals that once shaped our survival? And if the environment around us has changed so dramatically, what might have happened to the ancient awareness that our ancestors relied on every night they slept beneath the open sky? For early humans, awareness of the surrounding world was not something that happened only during hunting or moments of danger. It was part of ordinary life, repeated day after day across landscapes that were rarely quiet for long. A person walking across open ground might notice the direction of the wind because it carried the scent of water, animals, or smoke from distant fires. Someone gathering plants along a riverbank might listen for the sudden flight of birds, which sometimes reacted before humans could see the reason. These small signals formed a continuous flow of information. None of them were dramatic by themselves, yet together they created a picture of what was happening nearby. In environments where large predators and unpredictable weather were common, this quiet awareness helped people decide where to move, when to stay still, and when to leave an area. Archaeological evidence suggests that early human groups often moved through territories that changed with the seasons. Rivers shifted, grasslands expanded or shrank, and animal herds followed their own patterns across the land. In such settings, people could not depend on fixed structures or permanent defenses. Their safety depended largely on their ability to notice changes around them. When the environment shifts slowly, humans can learn its patterns. But when something breaks those patterns, the difference often appears first in small details. A herd of grazing animals may suddenly lift their heads and stare in one direction. The normal sounds of insects or birds may fall silent for a moment. The movement of grass may reveal a shape that does not belong to the wind alone. Experienced observers learn to recognize these interruptions. Studies of modern hunter-gatherer communities have shown that people who spend much of their lives outdoors often become highly attentive to these subtle changes. They are not necessarily thinking about danger every moment. Instead, their senses remain quietly open to what the environment is doing. This type of attention develops through constant exposure to natural settings. Children who grow up in such environments often learn to notice tracks in soil, broken branches, or faint sounds that others might overlook. These skills are not mysterious. They are the result of repeated experience with landscapes where small signs matter. The human sensory system is well suited to this kind of observation. Our hearing can detect very slight differences in sound, especially sudden changes in rhythm or direction. Our vision is particularly sensitive to movement at the edges of our field of view. Even when we are not focusing directly on something, the brain continues to monitor patterns in light, motion, and sound. When something unusual appears, attention shifts almost automatically. Neuroscientists describe this as a background process, in which the brain constantly compares incoming sensory information with what it expects to perceive. If a pattern suddenly changes, the brain quickly directs attention toward it. This system does not require deliberate thought. It operates quietly, often outside conscious awareness. In natural environments where small disturbances could signal the presence of another animal, this ability would have been extremely useful. Over long periods of human evolution, individuals who reacted quickly to unexpected signals may have avoided dangers that others did not notice in time. Gradually, this sensitivity became part of the broader design of the human nervous system. Yet the world in which most people now live is very different from the one in which these abilities developed. In cities and towns, many of the signals that once carried meaning are masked by constant background noise. Engines, electrical systems, and human activity create layers of sound that rarely stop. Artificial lighting also changes the way humans experience darkness. For most of our species' history, night arrived slowly with the setting sun, and the landscape became quieter and more uncertain. Today, night is often filled with light and predictable surroundings. Buildings separate people from the wind, the soil, and many of the natural movements that once surrounded human life. When the environment no longer requires constant attention to small signals, the habit of noticing them may begin to fade. People still possess the same basic sensory systems, but the way those systems are used can change with lifestyle and environment. If our ancestors once relied on subtle awareness every day, the modern world may quietly be reshaping how often that ancient attention is needed. Across the long span of human history, the relationship between people and their surroundings was immediate and continuous. Most daily activities took place outdoors or in simple shelters where the sounds and movements of the environment remained clearly present. A person resting beside a small fire at night might hear distant animals moving across the ground. Someone sleeping near the entrance of a temporary shelter could feel the shift of cooler air as the wind changed direction. These details were not unusual experiences. They formed part of the ordinary background of life. For early humans, the boundary between the body and the landscape was thinner than it is for many people today. Archaeological research shows that human groups often selected camp locations carefully, choosing areas that offered good visibility or natural barriers such as rocks, trees, or slopes. These choices suggest that awareness of the surrounding environment was always important. Even when people rested, the environment continued to communicate through quiet signals. A sudden silence among animals could suggest that a predator was nearby. The smell of smoke carried by wind might reveal the presence of another human group in the distance. These signals rarely provided clear answers on their own, yet they contributed to a larger sense of what was happening around a camp or along a travel route. The human body is well adapted to this type of subtle observation. Our ears are capable of detecting extremely small changes in sound, particularly when a new sound interrupts a steady background. Our eyes can recognize movement quickly, even when the object is small or partially hidden. At the same time, the brain constantly organizes incoming sensory information, separating familiar patterns from unusual ones. This process happens automatically. People often notice something has changed before they consciously understand why they feel alert. Scientists who study perception sometimes describe this as the brain's ability to detect pattern violations. When the environment behaves as expected, attention remains relaxed. When something interrupts that pattern, awareness rises. In landscapes where human ancestors lived, such interruptions could have many causes. An approaching animal might disturb birds or insects before it became visible. The movement of grass might reveal an animal moving through it. Even changes in smell carried by the wind could signal that something unfamiliar had entered the area. None of these signals guaranteed danger, yet each one provided information that the brain could interpret. Over thousands of generations, individuals who responded quickly to these signals may have been better able to avoid threats or locate food. Gradually, this responsiveness became part of the way human attention operates. Modern humans still possess this underlying system. Many people have experienced moments when they suddenly become aware of something unusual in their surroundings, such as a quiet noise behind them or a movement in the corner of their vision. These experiences reflect the same sensory abilities that helped early humans interpret their environment. However, the conditions that once required constant attention have changed significantly. In many parts of the modern world, people spend most of their time indoors. Walls reduce the sounds of wind, animals, and distant movement. Artificial lighting removes much of the darkness that once shaped human perception at night. Transportation and machines produce steady background noise that masks subtle sounds. As a result, the environment around modern humans often becomes more predictable and less dependent on natural signals. When an ability is used less often, the brain may gradually rely on it less in daily life. This does not mean the ability disappears completely, but it may become quieter and less practiced. The ancient sensitivity that once helped humans interpret forests, grasslands, and rivers may still exist within the nervous system. Yet modern environments provide fewer opportunities to use it regularly. If early humans depended on noticing small changes in their surroundings, then understanding how that awareness once worked may reveal something important about our species. It suggests that human perception was shaped by landscapes where attention to subtle signals mattered every day. And it raises a thoughtful question about the present. If our ancestors lived in constant dialogue with their environment, quietly noticing patterns of sound, movement, and scent, how much of that ancient awareness remains active in the lives of people today? The human brain did not appear in its current form overnight. It developed slowly across hundreds of thousands of years while early humans moved through landscapes that demanded careful attention. Unlike many animals that rely mainly on strength, speed, or sharp claws, Humans depended heavily on the ability to notice changes in their surroundings and respond quickly. This reliance shaped the way the brain processes sensory information. Even today, the human nervous system is designed to detect patterns in sound, motion, and light with surprising sensitivity. One reason for this lies in how the brain organizes incoming signals from the senses. At every moment, enormous amounts of sensory information reach the brain through the eyes, ears, skin, and nose. Yet people are not overwhelmed by these signals because the brain constantly filters them. It compares what is happening now with what usually happens in the same environment. When the pattern remains stable, attention relaxes and the brain allows many details to remain in the background. But when something changes unexpectedly, attention rises almost immediately. A small movement in the corner of the eye can redirect the gaze before the person consciously decides to look. A sudden sound can cause the head to turn toward it within a fraction of a second. These reactions are not learned habits alone. They are part of the basic structure of the human brain. Researchers studying perception have shown that humans are especially sensitive to sudden changes in the environment rather than to steady, predictable signals. This ability would have been extremely useful for early humans living in natural settings. In forests or open grasslands, the environment is full of repeating patterns. Wind moves through vegetation, insects produce steady background sounds, and animals follow familiar paths across the land. When these patterns remain unchanged, the environment feels calm, but when something interrupts them, it may indicate the presence of another animal or a shifting situation that requires attention. The brain is designed to notice these interruptions very quickly. One important region involved in this process is the system that helps direct attention toward new or unexpected stimuli. When a sudden sound occurs, signals travel rapidly from the ear to areas of the brain responsible for orientation and awareness. The body often reacts before conscious thought has time to interpret the event. The eyes move toward the source of motion, the ears focus on the direction of the sound. Muscles tighten slightly as the body prepares to respond if necessary. These responses are sometimes called orienting reactions because they help the body turn toward possible sources of information. Importantly, these reactions do not always signal danger. In many cases, the stimulus turns out to be harmless, such as a falling branch or an animal passing at a distance. Yet the system evolved to respond quickly because waiting too long could be costly in uncertain environments. Early humans shared their habitats with many other animals, including predators that relied on stealth and patience. In such circumstances, the difference between noticing a signal early and noticing it late could matter greatly. Over long periods of time, natural selection favored individuals whose nervous systems responded efficiently to unexpected changes in their surroundings. This does not mean that early humans were constantly fearful or tense. Instead, their brains were tuned to remain quietly attentive while daily life continued. People could walk, gather food, speak with others, or rest beside a fire while their sensory systems monitored the environment in the background. When something unusual occurred, attention shifted quickly and naturally. Modern neuroscience shows that this ability still exists within the human brain. Even in quiet indoor settings, people often notice sudden sounds or movements automatically. However, the modern environment presents the brain with a different kind of sensory world. Instead of the subtle patterns of forests, grasslands, and rivers, many people now experience steady artificial sounds, bright lighting, and structured spaces. These conditions provide fewer natural signals that require careful interpretation. When the brain encounters fewer meaningful changes in the environment, the ancient systems that once monitored the landscape may become less active in everyday life. This does not remove the underlying ability, but it may change how often it is used. If the human brain evolved to detect small environmental signals with remarkable efficiency, then understanding how that system once functioned may help explain why some individuals today still appear unusually sensitive to their surroundings, while many others rarely notice such subtle cues. If we look more closely at how the human brain processes the world, we find that much of our awareness operates quietly in the background. People often imagine attention as something deliberate, as if the mind chooses one object and studies it carefully. Yet a large part of human perception happens before deliberate thought begins. The brain constantly scans the environment for patterns, comparing what is happening now with what it expects to happen next. When the pattern continues normally, the brain allows the information to pass without much attention, but when something unusual appears, attention shifts automatically. This process can be observed in everyday life. A person may be speaking with a friend while sitting in a quiet room, hardly noticing the steady hum of distant traffic or the soft movement of air through a window. Yet if a sudden noise interrupts that background sound, the head often turns instantly toward the source. The person did not decide in advance to listen for that noise. The reaction happened before conscious planning. The same principle applies to movement. Humans are especially sensitive to motion that appears suddenly or moves in unexpected ways. Even when people are not directly looking at something, the edges of the visual field remain alert to changes. A quick movement in peripheral vision can attract attention almost immediately. This ability is not unique to humans, but in our species it is closely connected to the way the brain organizes attention. Early humans spent long periods moving through environments where visibility was often limited by vegetation, terrain, or low light. In such conditions, noticing small motion at the edge of vision could provide valuable information about nearby animals or other people. The brain gradually develops systems that prioritize unexpected movement, allowing the eyes and head to orient toward it rapidly. Hearing also plays a central role in this process. Sound travels through environments even when objects cannot be seen. A person walking through tall grass may hear a faint rustle before any movement becomes visible. Water flowing in a river may change its rhythm when something disturbs it upstream. Because sound can carry information across distance and around obstacles, the human auditory system is especially tuned to detect sudden differences in tone or rhythm. Research in auditory perception shows that the brain is particularly sensitive to abrupt changes in sound patterns. A consistent background noise may fade from conscious awareness, yet a slight interruption within that noise can stand out clearly. This ability helps people identify new events within a complex acoustic environment. Early humans living outdoors would have encountered many situations where this sensitivity was useful. The night environment offers a clear example. When darkness limits visual information, hearing becomes an even more important guide. The quiet sounds of insects, wind, and distant animals create a background pattern. If that pattern changes suddenly, attention may rise immediately. Many people today have experienced waking briefly during the night after hearing a faint or unfamiliar sound. Often the sound turns out to be harmless, but the brain reacted quickly because it detected a change in the environment. This response reflects the same sensory system that evolved in earlier human environments. However, the modern sensory world is structured very differently. In many cities, sound patterns remain constant throughout the night. Traffic, electrical systems, and urban activity create continuous background noise that rarely disappears completely. Artificial lighting also alters the way humans experience darkness. Streets, buildings, and homes often remain illuminated long after sunset. These conditions change the signals that reach the senses. When background noise is constant, the brain may become less responsive to subtle variations within it. When light remains steady through the night, the contrast between darkness and illumination becomes less meaningful. Over time, these environmental changes may influence how frequently certain sensory abilities are used. The brain remains capable of detecting small changes, yet the opportunities to practice this awareness become less common in everyday life. Understanding this shift does not suggest that modern humans have lost their sensory abilities entirely. Instead, it highlights how closely perception is linked to environment. The human brain was shaped in landscapes where attention to small signals carried practical meaning. As those landscapes changed, the patterns of attention within daily life may have changed as well. If the ancient human brain evolved to monitor the environment almost constantly, the question remains whether modern environments encourage the same quiet awareness, or whether they slowly guide attention toward different kinds of signals. As the brain receives information from the senses, it does more than simply record what is happening. It also predicts what should happen next. This predictive ability allows humans to move through the world without carefully analyzing every sound or movement they encounter. When a person walks along a familiar path, the brain expects certain patterns. The sound of footsteps, the rhythm of breathing, the gentle motion of surrounding plants in the wind. These expectations create a stable background. As long as the environment follows these patterns, attention remains relaxed and the mind can focus on other tasks such as conversation, planning, or gathering food. But when something violates the expected pattern, the brain quickly shifts attention toward the difference. In many ways, human perception works like a quiet comparison between expectation and reality. Neuroscientists often describe this process as the brain constantly updating its internal model of the world. The model is built from experience. Each time a person moves through an environment, the brain stores information about how that environment usually behaves. Over time, these experiences create expectations about sound, light, movement, and rhythm. When the present moment matches those expectations, perception feels smooth and predictable. But when something appears that does not belong to the pattern, the brain reacts rapidly. This reaction does not always involve conscious thought. Sometimes people feel alert or uneasy without immediately knowing why. A faint sound, a subtle movement, or a shift in atmosphere may have triggered the brain's detection system before the mind has fully identified the cause. In natural landscapes where humans evolved, this sensitivity to unexpected change would have been especially valuable. The environment often followed stable rhythms that could be learned through experience. The wind moved through grasses in familiar ways. Birds produced repeated patterns of calls. Insects created steady background sounds that filled the air at certain times of day. When those patterns changed, the difference could carry meaning. A group of animals passing nearby might disturb birds or silence insects for a moment. A predator moving quietly through vegetation might produce just a brief disruption in the usual rhythm of sound. Early humans did not need to identify the exact cause immediately. Simply noticing that something had changed could prompt a moment of attention or caution. Archaeological and anthropological observations suggest that people living in close connection with natural landscapes often develop a strong familiarity with these patterns. They recognize how a place usually behaves during different times of day or seasons of the year. When something breaks that pattern, it stands out clearly. This kind of awareness does not require special training in a formal sense. It emerges gradually through repeated experience with the same environments. Over many years, individuals become familiar with the subtle details of wind, water, animal activity, and vegetation. The brain quietly stores these experiences and uses them to interpret new sensory information. The ability to detect unusual changes is therefore not simply a matter of sharp senses alone. It also depends on the brain's memory of how the environment normally behaves. And quote, "Yet the environments in which many people live today provide fewer opportunities to build this kind of familiarity. Modern settings often change rapidly and contain signals created by machines rather than natural processes. Traffic sounds vary unpredictably. Artificial lights remain steady regardless of the time of day. Buildings separate people from many of the natural cues that once shaped daily life. Because of this, the brain receives different types of sensory patterns than those experienced by earlier humans. Instead of slowly learning the rhythms of wind, animals, and vegetation, modern perception often adapts to structured spaces where the environment behaves in more controlled ways. This shift does not mean that the human brain has changed completely. The underlying system that compares expectation with reality remains present. People still notice sudden noises or unusual movements in their surroundings. However, the kinds of signals that attract attention may now be different from those that shaped human perception in the distant past. If ancient environments trained the brain to notice subtle changes in natural patterns, the modern world may be guiding attention toward other forms of information. This contrast between past and present invites a deeper reflection about human perception. The brain still carries the systems that once helped our ancestors interpret the landscape around them, but the environments that shape those systems have changed dramatically. When the world around us no longer resembles the landscapes in which our senses evolved, it becomes possible that some aspects of our ancient awareness remain within us, waiting quietly in the background, rarely called upon in daily life. For most of human history, night was not simply the absence of daylight. It was a very different sensory world, one that shaped how people listened, moved, and rested. When the sun disappeared below the horizon, the landscape did not become completely silent. Instead, many daytime sounds faded while other sounds slowly appeared. Insects began to fill the air with steady rhythms. Nocturnal animals moved through grass, leaves, and branches. The wind carried faint noises across long distances. For early humans, night required a different kind of awareness than daytime. Vision became less reliable, and hearing often took a more important role in understanding the environment. Archaeological evidence shows that fire played an important role in human life for hundreds of thousands of years. Small fires provided warmth, light, and some protection from animals. But even with fire, early humans did not live in brightly illuminated spaces like modern homes. The light from a fire reaches only a short distance into darkness. Beyond that small circle of light, the surrounding landscape remained mostly hidden. In such conditions, people depended heavily on subtle sensory information to understand what was happening nearby. The sound of movement beyond the firelight could carry important meaning. A faint rustle in dry leaves might suggest a small animal passing through. A heavier movement might indicate something larger. The direction of the sound could reveal whether it was approaching or moving away. These interpretations were rarely certain, yet they formed part of how humans navigated the night environment. Anthropologists studying communities that still spend long periods outdoors often describe how people gradually become comfortable with these nighttime signals. Instead of experiencing darkness as complete silence, they learn to recognize the different layers of sound that fill the night landscape. Some sounds repeat regularly and become familiar, such as insects or the movement of wind through trees. Other sounds appear suddenly and draw attention because they interrupt the pattern. When this happens, the brain naturally shifts into a more alert state, listening carefully for further information. This response reflects the same neural systems that evolved during earlier periods of human history. The human brain is especially responsive to unexpected sensory events in low-visibility environments. When vision provides limited information, hearing becomes a primary guide to the surrounding world. Many studies in human perception show that people often become more attentive to sound in darker environments. This does not necessarily mean they hear better in a physical sense, but rather that the brain places greater emphasis on auditory signals when visual cues are reduced. Early humans likely relied on this shift in attention frequently during the night. The campfire created a small center of activity where people could rest, prepare food, or speak quietly with others. Yet the surrounding darkness remained an important part of the environment. The sounds beyond the firelight carried information about animals, weather, and other human groups moving through the landscape. Over many generations, the ability to remain quietly aware of these nighttime signals may have become a normal part of human life. Sleeping patterns may also have reflected this environment. Anthropological observations suggest that in some traditional societies, people do not always sleep through the night in a single uninterrupted period. Instead, sleep can occur in segments, with brief awakenings between them. During these quiet moments, individuals may listen to the surrounding environment before returning to sleep. These observations provide a glimpse into how human sleep and awareness might once have been connected to the rhythms of natural landscapes. In contrast, modern environments often reduce the sensory uncertainty of night. Electric lighting removes much of the darkness that once shaped human perception after sunset. Walls and insulation block many of the sounds that would otherwise travel through the night air. Machines and electrical systems create steady background noise that remains constant through many hours of darkness. As a result, the nighttime environment experienced by modern humans can feel very different from the one that shaped earlier generations. The brain still carries the ancient systems that respond to unexpected sounds in the dark, yet the signals that once activated those systems appear less frequently in everyday life. If human awareness during the night once depended on interpreting subtle environmental cues, then the transformation of nighttime environments may have changed how often those ancient abilities are used. Understanding how early humans experienced the night landscape may therefore help explain why certain sensitivities remain strong in some individuals while becoming quieter in others. When darkness spreads across a landscape, the human senses do not stop working. Instead, the brain begins to rely on them in slightly different ways. Vision becomes less precise when light fades, yet the ears continue to receive information from the environment. For early humans who spent much of their lives outdoors, this shift between vision and hearing likely happened every evening. As daylight slowly disappeared, attention naturally adjusted toward sounds that traveled through the night air. A quiet camp surrounded by darkness was never completely silent. The night carried layers of small signals that the brain could interpret. The sound of insects formed a steady background rhythm. Wind moved through grasses or leaves, producing patterns that repeated over time. Occasionally an animal moved through the environment, creating a short disturbance in those patterns. When such a disturbance occurred, the brain often responded immediately, even if the person resting near the fire remained mostly still. The head might tilt slightly, or the eyes might open briefly in the darkness. These reactions are familiar even to people living in modern homes today. Many individuals have experienced waking suddenly after hearing an unfamiliar sound during the night, even when the sound is faint. Scientists studying sleep have observed that the brain does not completely disconnect from the environment while a person is asleep. Instead, parts of the nervous system continue to monitor important sensory signals, particularly sounds that differ from the normal background. This ability appears to have deep evolutionary roots. For humans living in open landscapes, remaining partly responsive to the environment during sleep may have provided an advantage. A sleeping group could still react to sudden disturbances such as approaching animals or unexpected movement nearby. Anthropologists observing traditional societies have sometimes noted that sleep in natural environments may involve brief periods of wakefulness during the night. During these moments, people may quietly listen to the surrounding sounds before returning to sleep. This pattern does not necessarily mean that individuals are anxious or fearful. Instead, it reflects a form of awareness shaped by environments where the night landscape continues to communicate through subtle signals. Over time, the brain learns the normal rhythm of those signals. Insects produce familiar patterns of sound. The wind creates predictable movements in vegetation. When those rhythms continue steadily, the environment feels calm. But when something interrupts them, attention may rise quickly, even during sleep. The brain is especially sensitive to these interruptions. Research in auditory neuroscience shows that humans are very good at detecting changes in sound patterns while resting. The brain can recognize when a new sound does not belong to the usual background noise. This ability helps explain why a person may sleep through constant sounds such as rainfall or a fan, yet wake quickly when hearing a sudden, unfamiliar noise. In natural settings, this sensitivity would have allowed early humans to respond quickly if the environment changed during the night. Yet the nighttime world experienced by many modern humans is very different. Artificial lighting often removes the deep darkness that once covered landscapes after sunset. Indoor environments isolate people from many outdoor sounds. Buildings block the movement of wind, animals, and distant activity. At the same time, urban environments introduce new forms of constant noise such as traffic, machinery, or electrical systems. These sounds often continue throughout the night without significant change. When background noise becomes constant, the brain gradually adapts by filtering it out. This adaptation allows people to sleep despite the presence of steady sounds. However, it also means that many subtle environmental signals never reach the brain in the same way they once did in natural landscapes. The human sensory system still retains the ability to detect unusual sounds, yet the opportunities to use that ability in daily life may become less frequent. If early humans spent thousands of generations learning the quiet language of nighttime environments, the modern world may have altered that relationship in ways that are not always obvious. The brain still carries the ancient mechanisms that respond to changes in sound and movement, but the signals that once triggered them may now be hidden behind walls, artificial light, and steady mechanical noise. This difference between past and present raises an interesting possibility. Some individuals may remain particularly sensitive to subtle environmental signals, while others may rarely encounter situations that require such awareness at all. Across many generations of human history, nighttime awareness was not limited to a single individual. Early humans lived in small groups, and the safety of the group often depended on shared attention to the environment. When people rested near a fire or within a simple shelter, the surrounding darkness remained part of their living space. The night landscape continued to carry information through faint sounds, shifting air, and the distant movements of animals. In such conditions, awareness of these signals did not belong to one person alone. It was distributed across the group. Anthropological observations suggest that groups resting outdoors often develop a natural rhythm, in which some individuals remain lightly alert, while others sleep more deeply. This pattern does not require formal planning. It can emerge naturally because people do not all fall asleep at the same moment or wake at the same time. Some individuals may sit near the fire for longer periods, listening quietly while others rest. Later in the night, those roles may shift as different people wake briefly before returning to sleep. Over time, this quiet exchange of wakefulness can create a form of shared awareness that helps a group remain connected to its surroundings. The human brain supports this kind of distributed attention. Even when individuals are resting, the nervous system does not completely withdraw from the environment. Certain sounds can still pass through the sleeping brain and produce a small response. If one person hears something unusual and shifts position, the movement itself may alert someone nearby. In this way, subtle signals can travel through a group without the need for loud alarms or sudden activity. This kind of quiet coordination may have been especially useful in environments where remaining calm and attentive carried advantages. A sudden burst of noise could attract unwanted attention from animals or other human groups. By contrast, small signals interpreted quietly could allow people to respond without disturbing the surrounding landscape. Evidence from modern research on sleep shows that humans remain capable of processing certain environmental cues even during rest. Studies have found that the brain can still detect meaningful sounds, such as voices or unfamiliar noises, while a person sleeps. The brain does not interpret every sound fully, yet it remains capable of distinguishing signals that differ from the usual background. This ability may reflect the long evolutionary history of sleeping in environments where remaining partly responsive to the surroundings had practical value. Early humans likely experienced the night not as complete isolation from the environment, but as a quieter phase of awareness shaped by darkness and reduced activity. Within this quiet phase, the group remained loosely connected to the outside world through hearing and subtle perception. The environment around them continued to change through the night as animals moved, winds shifted, and temperatures cooled. Over many generations, the human brain may have adapted to this rhythm of rest combined with partial awareness. Yet the conditions that supported this pattern have changed significantly in modern societies. Most people now sleep inside enclosed buildings where many environmental signals are reduced or removed entirely. Walls block wind and distant movement. Artificial lighting keeps spaces illuminated long after sunset. Mechanical sounds from machines or electrical systems often remain constant through the night. These features create environments that feel stable and predictable compared with the landscapes in which earlier humans lived. As a result, the relationship between sleep and environmental awareness may have changed. The brain still carries the ability to respond to unusual sounds, but the environment may provide fewer meaningful signals that require attention. Instead of listening for subtle disturbances in natural patterns, many people sleep within spaces designed to minimize uncertainty. This shift may have gradually altered how often the ancient systems of nighttime awareness are used. The human nervous system still contains the structures that once helped individuals remain quietly alert to their surroundings. Yet those systems developed within landscapes that communicated constantly through sound, movement, and scent. When modern environments reduce those signals, the connection between sleep and environmental awareness may become less visible in everyday life. If early human groups once rested within a living landscape that never fully stopped speaking through subtle cues, the question becomes whether the modern world has softened that ancient dialogue between human senses and the surrounding night. The human body contains systems that respond to the environment even before conscious thought begins. Long before a person has time to analyze a situation, the body can react to subtle signals such as a sudden sound, an unexpected movement, or a faint change in the surrounding atmosphere. These reactions are not random. They are part of a network within the nervous system that helps the body prepare for possible changes in the environment. In natural landscapes where early humans lived, this system acted as a kind of early warning process. It allowed the body to shift from a relaxed state to a more attentive one within moments. When something unusual occurs nearby, the first reaction often happens inside the brainstem and deeper parts of the nervous system that regulate alertness. Signals from the ears or eyes travel rapidly to these areas where they can influence the body before conscious interpretation begins. A sudden noise may cause the shoulders to tense slightly or the head to turn toward the direction of the sound. A quick movement at the edge of vision may cause the eyes to shift before the person has fully identified what moved. These reactions can occur within fractions of a second. They are part of what scientists describe as automatic orienting responses. The purpose of these responses is simple. They help the body gather more information about a potential change in the environment. When the head turns toward a sound or the eyes move toward a motion, the senses are directed toward the source of the signal. From there, the brain can decide whether the event is harmless or requires further attention. Importantly, these reactions are not designed only for emergencies. They occur constantly in small ways throughout everyday life. People may glance toward a door when it opens quietly behind them or turn toward a faint sound in the distance. Most of the time, these signals turn out to be ordinary events. Yet the system remains active because it evolved in environments where ignoring certain signals could carry serious consequences. Early human environments were filled with animals that relied on stealth rather than speed. Predators such as large cats or hyenas often approached quietly, using cover from vegetation or darkness. In such situations, the first sign of their presence might be a brief disturbance in sound or movement. The ability to notice that disturbance quickly could allow a person to react before the animal was fully visible. Over many generations, individuals whose nervous systems responded efficiently to subtle signals may have had a greater chance of avoiding danger. This does not mean that early humans were constantly in fear. Rather, their bodies were tuned to remain quietly responsive to the environment around them. The same system also responds to signals that have nothing to do with predators. A sudden change in weather may be noticed through shifts in wind or temperature. The movement of animals may indicate new opportunities for hunting or gathering food. Even the approach of other human groups could first be detected through distant sounds carried across the landscape. In all these cases, the body's early warning responses help direct attention toward important changes in the environment. Modern research in physiology shows that these reactions involve multiple systems working together. The nervous system can influence heart rate, breathing, and muscle tension when something unusual occurs. These small adjustments prepare the body to move, listen, or look more carefully. Often the changes are so subtle that people barely notice them. Yet they form part of the continuous dialogue between the human body and the surrounding world. In environments where early humans lived, this dialogue happened constantly. The body remained quietly aware of sound, movement, and other sensory cues that could reveal important information about the landscape. However, the modern environment presents a very different sensory experience. Many people spend large portions of their time in buildings designed to limit unpredictable signals. Walls reduce the sounds of distant movement. Artificial lighting removes the strong contrast between darkness and light that once guided human attention. Machines create steady background noise that masks small variations in sound. As a result, the early warning systems within the body may receive fewer signals that require immediate attention. The underlying mechanisms remain present within the human nervous system, yet the environment may call upon them less frequently. Understanding how the body once functioned as a sensitive detector of environmental change may help explain why certain individuals today still appear especially responsive to subtle cues in their surroundings. Inside the human body, awareness of the environment is not limited to the senses alone, but it also communicates through internal signals that often appear before a person has time to think about them clearly. When something unexpected happens nearby, many people feel a brief shift inside the body. The heartbeat may change slightly, breathing may pause for a moment, muscles may become a little more tense. These reactions are subtle, yet they form part of the way the body prepares to respond to possible changes in the environment. Scientists who study physiology often describe this process as part of the body's alertness system. It links the brain with the heart, lungs, and muscles, allowing the body to adjust quickly when new information appears. In natural environments where early humans lived, these small reactions may have helped individuals remain prepared for sudden movement or action. When the body becomes slightly more alert, attention also becomes sharper. Sounds may seem clearer, and small movements may be easier to notice. This shift can happen quickly and then fade again once the brain determines that the environment remains safe. Many people have experienced this feeling without necessarily understanding its cause. A person walking through a quiet place may suddenly feel more attentive for a brief moment, even before identifying what changed. Later they might notice a small sound or movement that triggered the reaction. In such moments, the body often reacts before conscious thought has caught up with the signal. This pattern reflects the long evolutionary history of human interaction with unpredictable environments. Early humans moved through landscapes where important information often appeared in small and uncertain forms. A distant sound could indicate animals moving through vegetation. The sudden flight of birds might reveal the presence of something larger approaching. A faint smell carried by the wind could signal water, fire, or other human groups nearby. None of these signals provided complete information by themselves, yet the body's alertness responses helped individuals pay attention at the right moment, allowing the brain to gather more details from the environment. Anthropologists studying traditional societies have sometimes noted that experienced hunters and gatherers often describe a quiet sense of noticing when something in the landscape changes. They may pause briefly, listen carefully, and then continue moving once they understand the situation. These observations do not suggest mysterious abilities. Instead, they illustrate how repeated experience with natural environments can strengthen the connection between subtle sensory signals and the body's internal awareness. Over time, individuals become familiar with how their bodies react to certain environmental changes. This familiarity allows them to interpret those reactions more easily. The body therefore becomes part of the process of interpreting the landscape. Modern neuroscience supports the idea that internal bodily signals can influence perception and decision-making. The brain continuously receives information not only from the outside world, but also from within the body itself. Changes in heart rhythm, breathing patterns, and muscle tension can all contribute to the sense that something in the environment requires attention. These signals are often processed quietly without reaching full conscious awareness. Yet they still influence how people respond to their surroundings. In the environments where early humans lived, this close connection between body and environment likely played an important role in daily life. The body's small adjustments helped individuals remain responsive to subtle signals without needing constant deliberate focus. This allowed people to move, rest, and interact with others while still remaining connected to the landscape around them. However, the environments in which many people now live provide different kinds of sensory experiences. Modern buildings often reduce exposure to natural sounds, smells, and movements. Artificial lighting and controlled indoor climates create spaces that remain stable and predictable across long periods of time. In such conditions, the body may encounter fewer situations that require these small adjustments in alertness. The underlying systems remain present within the nervous system, yet they may be used less frequently in everyday life. When an ability is not used regularly, people may become less aware of how it feels or how to interpret it. The body still responds to unexpected events, but the signals may be overlooked or misunderstood because modern environments rarely require careful interpretation of subtle environmental changes. This difference between past and present raises an important possibility. The ancient relationship between the human body and the surrounding landscape may still exist within our biology, even if modern life has made it less visible in everyday experience. Over long stretches of human evolution, the connection between the body and the environment was not an occasional experience, but a continuous condition of daily life. People moved through landscapes where the ground, air, and surrounding life constantly produced signals that could influence decisions. The body's subtle reactions, changes in breathing, shifts in posture, a brief tightening of muscles were part of how humans stayed responsive to these signals without needing to analyze them consciously every moment. This quiet responsiveness allowed early humans to balance two important needs. On one hand, they had to remain attentive to the environment in order to notice potential dangers or opportunities. On the other hand, they also needed to conserve energy and avoid constant tension. The body solved this balance by maintaining a flexible state between relaxation and alertness. Most of the time, people could remain calm while the nervous system monitored the environment quietly in the background. When a small signal appeared, the body could shift slightly toward greater alertness before returning to a relaxed state again. This pattern is still visible in modern physiology. When a person hears an unexpected sound, the body often pauses briefly. Breathing may stop for a moment while the brain gathers information. The ears and eyes focus toward the source of the disturbance. If the brain determines that the situation is harmless, the body gradually returns to its previous state. These reactions happen so quickly that people often forget them a few seconds later, yet they reveal how closely the body remains linked to the surrounding environment. In earlier human settings, this system likely helped individuals interpret landscapes that were constantly changing. Weather conditions could shift quickly, bringing sudden wind, rain, or changes in temperature. Animals moved across the land in search of food or water. Other human groups might travel through the same territory at different times. Each of these events produced small disturbances in the usual patterns of sound, smell, or movement. The body's early responses helped draw attention to those disturbances before the brain had fully identified their cause. Anthropological research has shown that individuals who spend long periods in natural environments often become skilled at recognizing these subtle signals. Hunters moving quietly through forests may notice when birds suddenly change their calls. People traveling across open ground may sense a shift in wind direction that carries new scents from distant areas. These observations are not extraordinary abilities in themselves. They reflect the gradual learning of how the environment communicates through small patterns. Over many generations, human physiology developed in close interaction with this kind of sensory landscape. The body's alertness system helped humans remain connected to the surrounding world without requiring constant conscious effort. In modern settings, however, the environment often behaves differently. Many indoor spaces are designed to remain stable and predictable. Temperature is controlled, lighting remains steady, and sounds from the outside world are reduced by walls and insulation. These conditions create comfort and safety, yet they also reduce the variety of signals that once shaped human awareness. When the environment rarely changes in subtle ways, the body has fewer opportunities to practice interpreting those changes. The alertness system still functions, but it may respond mostly to louder or more obvious events rather than to delicate environmental cues. Over time, this shift can influence how people experience their surroundings. Some individuals may rarely notice faint changes in sound or movement because modern environments do not require that level of attention. Others may still remain sensitive to small signals, especially if they spend more time in natural landscapes where those signals continue to appear. The human body therefore carries a system that was shaped in a world very different from the one many people now inhabit. The ancient landscapes of human evolution required constant yet gentle awareness of the surrounding environment. The modern world often replaces those landscapes with spaces designed to remove uncertainty. Yet the biological structures that once connected the body to those earlier environments still remain within us. They continue to respond when unexpected signals appear, even if such signals now occur less frequently than they once did across the long history of our species. Human history stretches far beyond the written records preserved in books and documents. For the vast majority of our species' existence, people lived in small groups that moved through forests, grasslands, and river valleys in search of food. These societies, often described as hunting and gathering communities, offer one of the closest windows researchers have into how human life may have functioned before agriculture and cities became common. Anthropologists have spent many decades observing groups that continue to live partly in this way today. While these communities exist in modern contexts and cannot represent the past perfectly, their daily interactions with the environment often reveal patterns that help scientists understand how human awareness developed in natural landscapes. One of the most noticeable features reported in these observations is the quiet attention people give to the world around them. When individuals move through the land searching for plants, animals, or water, they often watch and listen carefully for small details. Tracks in the soil may reveal the direction an animal has traveled. A broken branch might indicate that something large passed through recently. Even subtle changes in the behavior of birds or insects can provide clues about what is happening nearby. These signals are rarely dramatic. Instead, they form a continuous stream of information that experienced individuals learn to interpret over time. For example, hunters may observe that certain birds produce alarm calls when a predator moves through their territory. If those calls suddenly appear in the distance, they may pause and listen carefully before continuing their path. Similarly, the movement of grazing animals across open ground can reveal changes in wind direction or the approach of other animals. These observations are not guesses. They emerge from long familiarity with the patterns of the landscape. People who grow up in environments where these signals matter often learn to recognize them gradually during childhood. Children accompanying adults during daily activities may watch how elders examine footprints, listen to distant sounds, or study the movement of animals across the horizon. Over many years, these skills become part of ordinary awareness. The brain slowly builds a detailed memory of how the environment behaves during different seasons, weather conditions, and times of day. When something disrupts those patterns, it becomes easier to notice. Importantly, this form of awareness does not require constant concentration. Experienced individuals often appear relaxed while moving through the environment, yet they remain quietly responsive to changes around them. Anthropologists sometimes describe this as a form of open attention. Instead of focusing on one object intensely, the mind remains receptive to many small signals at once. When something unusual appears, attention shifts naturally toward it. This style of perception may reflect the conditions in which human cognition developed over thousands of generations. Early humans lived in landscapes where useful information often appeared in subtle ways rather than through large, obvious events. The rustling of grass might reveal an animal hidden from view. The direction of a scent carried by the wind could suggest nearby water or other human groups. These cues required sensitivity to small environmental patterns rather than constant visual confirmation. Modern studies of perception support the idea that the human brain is capable of integrating many small signals at once without conscious effort. Sensory information from sound, vision, and smell can combine to form a broader sense of what is happening nearby. In natural environments where early humans lived, this ability would have helped individuals maintain awareness while still engaging in daily tasks, such as gathering plants, preparing tools, or caring for children. Yet the relationship between humans and their environment has changed dramatically in recent centuries. Many people today live in environments where food arrives through markets rather than through direct interaction with landscapes. Transportation replaces long travel across natural terrain. Buildings shield individuals from many of the signals that once informed human movement and decision-making. As a result, the types of environmental cues that once shaped everyday awareness appear less frequently in daily life. When those cues are rarely encountered, the skills associated with interpreting them may gradually become less familiar. Anthropological observations, therefore, suggest an important idea. Human perception developed in close partnership with landscapes filled with subtle information. When that partnership becomes weaker, the forms of attention that once helped people interpret the environment may begin to fade quietly from ordinary experience. In many natural landscapes, the environment communicates through patterns that become familiar to those who spend long periods observing them. The movement of animals follows certain routes across the land. Birds gather in particular places at certain times of day. Insects produce different sounds depending on temperature, light, and season. People who live closely with these landscapes gradually learn these rhythms, in the same way someone might learn the sounds of a neighborhood street. Over time, the brain begins to recognize what is ordinary and what is unusual. Anthropologists who have worked with communities that hunt and gather food often describe how experienced individuals pay attention to these patterns without appearing to concentrate intensely. A person may walk across open ground while speaking with others, yet still notice a faint trail in the soil or the distant movement of animals on a hillside. This type of awareness is not necessarily dramatic or mysterious. Instead, it reflects a long familiarity with environments where small changes can carry useful information. For example, animal tracks provide clues about movement that occurred earlier in the day or even during the night. The direction of a footprint, the depth of the impression in the soil, and the spacing between steps can all reveal details about an animal's size and behavior. These observations help people understand what has passed through an area even when the animal itself is no longer visible. Similarly, experienced observers often watch the behavior of birds. Many bird species produce alarm calls when they notice predators or unfamiliar movement nearby. These calls can travel across long distances, allowing attentive listeners to recognize that something has disturbed the normal rhythm of the environment. A sudden burst of alarm calls may prompt someone to pause and look more carefully at the surrounding landscape. Another source of information comes from changes in smell carried by the wind. In open environments, scent can travel surprisingly far. The smell of animals, smoke, or water may reach a person before the source becomes visible. People who spend much of their lives outdoors often become familiar with these signals, learning how wind direction influences what can be detected from a distance. None of these observations require extraordinary senses. The human nose, ears, and eyes already possess the ability to detect these cues. What matters most is repeated exposure to environments where such information is meaningful. When individuals grow up learning how to interpret tracks, sounds, and scents, the brain gradually organizes these signals into patterns that become easier to recognize over time. In this way, perception becomes closely connected with experience. The brain learns to anticipate what normally occurs in a particular place. When something interrupts that pattern, attention shifts naturally toward the change. Researchers studying perception sometimes describe this process as the brain developing a detailed internal map of its environment. This map does not consist only of visual images. It also includes expectations about sound, smell, and movement. In natural landscapes where early humans lived, such maps would have helped individuals interpret the environment quickly and efficiently. When a new signal appeared, the brain could compare it with stored memories of how the landscape usually behaved. If the signal did not match those expectations, attention increased automatically. This system allowed humans to remain aware of many small details without needing to analyze each one consciously. Over long periods of time, this style of perception may have become deeply integrated into human cognition. However, the modern world often offers fewer opportunities to build these kinds of environmental maps. People frequently move between buildings, vehicles, and streets where many sensory signals remain controlled or repetitive. Sounds created by machines often replace the varied rhythms of wind, animals, and water. Visual surroundings may change rapidly as people travel between different constructed environments. In such conditions, the brain still forms internal maps, but the signals that shape those maps are different from those that guided earlier human awareness. Instead of interpreting bird calls or animal tracks, attention may focus on traffic sounds, digital alerts, or the movement of other people in crowded spaces. The ancient sensory abilities remain within the human nervous system, yet the environments that once gave them meaning may appear less often in everyday life. When those environments become rare, the quiet awareness that once helped humans interpret subtle natural patterns may slowly become less familiar across generations. As these observations accumulate over years of living in close contact with natural landscapes, a person's awareness of the environment can become remarkably refined. Yet this refinement does not necessarily appear as a special skill in the way modern people often imagine expertise. Instead, it becomes part of ordinary perception. Someone walking across open ground may simply feel that a place is quiet in an unusual way. Another person may pause briefly after hearing a distant bird call that does not match the usual pattern of the morning. These reactions often happen before the person fully explains the reason for them. The brain has already compared the present moment with many past experiences and recognized a difference. Anthropologists have described similar moments during field research with communities who spend much of their lives outdoors. A group may be traveling across familiar land when one individual suddenly slows down or becomes more attentive to the surroundings. Others may follow the same pause, listening quietly before continuing. Sometimes the reason becomes clear soon afterward, such as the discovery of fresh tracks or the distant movement of animals. At other times, nothing obvious appears, and the group simply continues its path. What matters is that the pause itself reflects an awareness that something in the usual pattern of the landscape has changed. This kind of perception develops gradually through repeated contact with the same environment. People learn how a particular place behaves during different times of day or seasons of the year. They become familiar with how wind moves through certain valleys, how animals travel between water sources, and how insects sound when the air becomes warmer or cooler. These patterns form a background rhythm that the brain stores over time. When something interrupts that rhythm, the difference can be noticed, even if the cause remains unclear at first. In this way, perception becomes deeply connected with memory and experience. The brain does not interpret every signal independently. Instead, it compares each new signal with a long history of previous observations. If the new signal matches familiar patterns, it passes quietly through awareness. If it differs from those patterns, attention rises. This system allows people to move through complex environments without needing to analyze every detail consciously. The mind remains open to many small signals at once while focusing on daily tasks such as gathering food, walking across terrain, or speaking with others. Over long periods of human history, this form of awareness likely helped groups navigate landscapes where information was often subtle and incomplete. The environment rarely presented clear answers. Instead, it offered hints that required careful interpretation. A faint trail of footprints might suggest that animals had recently passed through an area. The sudden silence of birds might indicate movement in nearby vegetation. A change in wind direction might carry scents that reveal distant activity. Each signal alone may not provide certainty, yet together they form a broader understanding of the surroundings. However, as human societies gradually developed agriculture, permanent settlements, and later urban environments, the relationship between perception and landscape began to shift. Many daily activities moved indoors or into spaces designed to reduce unpredictability. Food became available through cultivation or trade rather than through direct observation of animal movement or seasonal plants. Transportation allowed people to travel long distances without closely observing the terrain between locations. These changes did not remove the human sensory system that evolved earlier, but they altered how often that system was used in daily life. When subtle environmental cues are rarely needed for survival, attention may slowly adapt to other types of information. People may become highly skilled at interpreting written language, digital signals, or the behavior of complex social systems, while paying less attention to faint sounds in the wind or distant animal movement. The human brain is remarkably flexible and capable of adjusting to new forms of information. Yet beneath these adaptations, the deeper sensory systems that once helped our ancestors read the landscape remain present. They are part of the same nervous system that developed across countless generations of interaction with natural environments. Understanding this long relationship between perception and landscape helps reveal why certain individuals today may still notice subtle environmental signals more readily than others. The ability itself did not suddenly appear in modern times. It was shaped slowly through the deep history of human life in landscapes where paying attention to small details could carry meaning. Long before written education or formal instruction existed, most human knowledge passed from one generation to the next through daily experience. Children learned by watching the people around them and by moving through the same landscapes that shaped the lives of their families. In environments where people depended directly on natural resources, childhood was closely connected to the rhythms of the land. Young children often spent long hours outdoors accompanying adults as they gathered plants, collected water, or followed animal trails. During these activities, they gradually became familiar with the many small signals that filled the environment. A child walking beside an older family member might notice how the adult pauses briefly when birds begin calling in an unusual way. Another child might watch someone examine marks in the soil to determine which direction an animal had traveled. These moments rarely involved formal explanations. Instead, children observed patterns repeatedly over many years. The brain slowly organized these experiences into memories of how the landscape behaved. As children grew older, they began to recognize the same patterns for themselves. The human brain is especially responsive to learning during childhood. Research in developmental psychology shows that young minds absorb information from the surrounding world through constant observation and exploration. Children often notice details that adults overlook because they are still building their understanding of how things work. In natural environments, this curiosity can lead them to pay attention to subtle changes in sound, movement, and texture. A child may crouch to study insect tracks in soft soil or watch how wind moves through different kinds of grass. Through repeated encounters with these details, the brain begins to connect sensory signals with meaning. Over time, children develop a growing familiarity with the environment in which they live. They learn where certain animals are likely to appear, when plants become ready to gather, and how the landscape changes across seasons. These lessons are not stored as abstract rules, but as lived experiences tied to specific places. Because the learning occurs gradually, awareness of the environment becomes part of ordinary perception rather than a special effort. Anthropologists observing children in communities that maintain close relationships with natural landscapes have often noted how early this familiarity begins to develop. Even young children may recognize animal tracks or identify certain plants by sight. They often accompany older members of the group during daily tasks, gaining experience simply by being present. As they grow, their attention to environmental cues becomes more refined. They begin to notice details that younger children have not yet learned to interpret. This process shows how perception can be shaped by the conditions in which a person grows up. When childhood involves regular contact with natural landscapes, the brain receives thousands of opportunities to observe the subtle patterns of wind, animals, vegetation, and water. Each experience adds another layer to the internal map the brain forms of its environment. Over time, the mind becomes skilled at recognizing when those patterns change. In modern societies, however, childhood environments often differ greatly from those that shaped earlier generations. Many children spend much of their time indoors, surrounded by structured spaces designed for comfort and safety. Schools, homes, and urban neighborhoods provide stability and protection, yet they may offer fewer opportunities to interact directly with natural landscapes. Instead of learning the patterns of forests or grasslands, children often become familiar with the rhythms of buildings, streets, and digital devices. These environments contain their own signals and patterns, but they differ from those that guided human perception throughout most of our species' history. When childhood experiences emphasize indoor settings and technological environments, the brain still develops strong perceptual abilities. Yet those abilities may focus on different types of information than those that once shaped early human awareness. The ancient sensory systems remain present within the nervous system, but the kinds of signals that train them during childhood may have changed. Understanding how childhood environments influence perception helps reveal an important idea about human development. The brain is not only shaped by biology, but also by the landscapes in which people grow up. If earlier generations learned to read subtle environmental cues during childhood, then changes in how children experience the world may gradually influence how those ancient abilities appear in later life. As children continue to grow within an environment, their attention gradually shifts from simple observation to deeper understanding. During early years, many signals from the environment may simply appear as interesting sights or sounds. A bird flying suddenly from a tree, the rustle of grass in the wind, or the faint movement of animals in the distance may attract curiosity. Over time, repeated exposure allows the brain to connect these experiences with patterns. The same bird calls may appear whenever certain animals move nearby. The same rustling sound may occur when wind passes through a particular type of grass. Through repetition, the brain slowly begins to recognize relationships between events in the landscape. This process happens quietly and gradually. Children do not usually sit down to study the environment in a formal way. Instead, they absorb information through daily life. When they accompany older members of their group while walking, gathering food, or watching animals, they are exposed to countless small details. These details accumulate into a form of knowledge that becomes part of ordinary perception. Over many years, the brain builds an internal understanding of how the environment usually behaves. Researchers studying childhood learning often describe this process as pattern learning. The brain observes repeated experiences and gradually forms expectations about what normally happens. When a familiar pattern appears again, it feels ordinary. When something breaks that pattern, attention naturally increases. In natural environments, this form of learning may help individuals notice subtle changes more easily. For example, a child who has spent many seasons in the same landscape may learn how insects sound on warm evenings, or how birds behave during quiet mornings. If those sounds suddenly disappear or change rhythm, the difference may become noticeable even without conscious effort. The brain simply recognizes that something is different from what it has learned to expect. Anthropological studies suggest that this type of environmental familiarity often develops through years of patient observation rather than through direct instruction. Elders may occasionally point out tracks or explain certain signs, but much of the learning happens through experience. Children watch how adults move through the land and gradually adopt similar habits of attention. They learn where to look for small details and when to pause and listen more carefully. In this way, perception becomes shaped by everyday interaction with the surrounding landscape. Over time, this interaction may strengthen the connection between the senses and the environment. The ears become accustomed to distinguishing subtle differences in sound. The eyes learn to notice slight movement across wide areas of terrain. Even smell can provide information about animals, plants, or water sources. These abilities are not separate skills, learned one by one. They develop together as part of a broader familiarity with the environment. When individuals spend many years in the same landscape, their brains become deeply familiar with its patterns. However, the environments in which many children now grow up provide different types of experiences. Urban and indoor settings often contain fewer natural cues such as animal sounds, shifting wind patterns, or seasonal changes in vegetation. Instead, Children may encounter signals created by human technology, including electronic sounds, traffic noise, and artificial lighting. These signals also form patterns that the brain learns to recognize. Yet they do not necessarily require the same kind of subtle interpretation that natural landscapes once encouraged. When environmental signals become more predictable or repetitive, attention may adapt to those conditions. The brain still learns patterns, but the patterns themselves may involve different types of information. Instead of noticing distant animal movement or changing wind direction, attention may focus on digital notifications, moving vehicles, or human voices in crowded spaces. The human brain remains capable of interpreting subtle cues, yet the opportunities to practice that ability during childhood may depend strongly on the environment in which a person grows up. This difference in experience may help explain why some individuals seem naturally attentive to small environmental details while others rarely notice them. The underlying sensory systems are shared by all humans, but the ways in which those systems are shaped during childhood can vary greatly depending on the landscapes and experiences that surround them. As childhood experiences continue to shape perception, the brain gradually becomes familiar with how certain environments behave over long periods of time. A child who repeatedly walks through the same landscape begins to notice how that place changes across days, seasons, and years. The sound of insects may grow stronger during warm evenings and fade when the air cools. Certain birds may appear only at particular times of year. Plants may grow in predictable locations where water collects after rain. Through repeated encounters with these patterns, the brain slowly builds a detailed memory of the surrounding world. This memory is not stored only as visual images. It includes expectations about sound, movement, temperature, and even the feeling of wind against the skin. When a person becomes deeply familiar with these patterns, subtle changes become easier to detect. A place that feels slightly quieter than usual may draw attention even before the reason becomes clear. A change in wind direction may carry unfamiliar scents that cause someone to pause and look around. These reactions often happen automatically because the brain compares the present moment with many previous experiences stored in memory. If the environment behaves exactly as expected, awareness remains calm and steady. But when something differs from those expectations, attention naturally increases. In landscapes where early humans spent much of their time, this type of familiarity may have been especially important. Human groups often returned to the same areas repeatedly because those places provided reliable food, water, or shelter. Over time, individuals learned the rhythms of these locations in great detail. They recognized the sounds of animals that normally lived there and the times when those animals usually appeared. They noticed how the wind moved across open ground or through narrow valleys. When something disrupted these patterns, it could signal a change in the environment that deserved attention. This kind of awareness was not limited to adults. Children who grew up in these environments gradually absorbed the same knowledge through observation and participation in daily activities. As they matured, their understanding of the landscape deepened. They became familiar with the signs that indicated animal movement, weather changes, or the presence of other people nearby. Over many years, this process created individuals who could move through natural environments with quiet confidence because the brain had learned how those environments normally behaved. Modern childhood environments, however, often involve different kinds of spaces. Many children spend large portions of their day indoors, where temperature, lighting, and sound remain controlled. Instead of learning the rhythms of natural landscapes, they may become familiar with the predictable patterns of classrooms, buildings, and digital devices. These environments provide stability and safety, yet they offer fewer opportunities to observe the subtle signals that once shaped human perception. The brain still develops strong abilities to recognize patterns, but the patterns themselves may involve technology and social interaction rather than the movement of animals or the sound of wind across grass. This shift does not mean that modern children lack perceptual skills. On the contrary, they often become highly skilled at interpreting complex information within the environments they know best. However, the ancient sensory systems that evolved during earlier periods of human history may receive less practice in everyday life. The ears may hear fewer natural sounds that require interpretation. The eyes may observe fewer distant movements across open landscapes. The sense of smell may encounter fewer subtle environmental cues carried by wind or vegetation. As a result, the connection between perception and natural landscapes may become less familiar across generations. The human brain still carries the biological structures that once helped our ancestors interpret the world around them, yet the environments that originally shaped those structures have changed dramatically in many parts of the modern world. When childhood experiences no longer involve close interaction with natural landscapes, the ancient forms of environmental awareness that developed across thousands of generations may appear less often in everyday life. For most of the time that humans have existed as a species, the pace of change in the environment was slow. Landscapes shifted across long stretches of time through natural processes such as climate cycles, migration of animals, and gradual changes in vegetation. These changes were often subtle enough that many generations experienced similar conditions while moving through the same regions. The human body and brain, therefore, developed within environments that changed gradually. Evolution itself moves slowly, shaped by countless small differences that accumulate across thousands of generations. Because of this slow pace, the abilities that helped early humans survive were refined across immense spans of time. Sensitivity to sound, movement, and environmental patterns became deeply embedded within the nervous system. The human brain learned to interpret landscapes filled with natural signals such as wind across grass, animal movement, and shifting weather. For most of human history, these signals remained central to everyday life. However, during the relatively recent past of human history, the pace of environmental change began to accelerate. One of the first major shifts occurred when human societies began to practice agriculture. Farming allowed groups to settle in one place rather than moving constantly in search of food. Permanent settlements gradually replaced the temporary camps that earlier humans had used for thousands of years. As villages and later towns appeared, the relationship between humans and the surrounding landscape began to transform. Fields replaced some natural vegetation, and food sources became more predictable because people were actively cultivating plants and managing animals. This shift changed how people interacted with the environment on a daily basis. Instead of relying mainly on tracking wild animals or recognizing seasonal plants, many individuals began focusing on crops, livestock, and stored food. While environmental awareness remained important, certain skills related to interpreting subtle signs in wild landscapes may have become less essential for survival. Over many centuries, this pattern continued as societies developed more complex forms of settlement. Cities appeared, and human populations became increasingly concentrated in built environments. Walls, buildings, and roads gradually replaced large areas of natural terrain. In these environments, many natural signals became less visible or less important in everyday life. Instead of interpreting animal tracks or the movement of birds, people began responding more often to signals created by human activity, such as spoken language, tools, and organized work. The pace of environmental change increased even more dramatically during the last few hundred years with the rise of industrial technology. Machines, engines, and electrical systems introduced new kinds of sound and light into human environments. Artificial lighting allowed people to remain active long after sunset. Transportation systems moved individuals across long distances without requiring them to observe the landscapes between those locations closely. These transformations happened extremely quickly when compared with the slow pace of biological evolution. The human brain that developed over tens of thousands of years now operates in environments that have changed significantly within only a few generations. Evolution has not had enough time to redesign the nervous system to match these new conditions fully. Instead, the same sensory systems that once helped humans interpret forests, rivers, and grasslands now operate within cities, buildings, and digital networks. The signals reaching the brain may be different, but the underlying biological mechanisms remain largely the same. This contrast between biological history and environmental change creates an interesting situation. Humans carry sensory systems designed for landscapes rich in natural patterns, yet many people now live in environments where those patterns are less visible or less necessary for survival. When the environment changes faster than the body can evolve, the abilities shaped by earlier conditions may continue to exist even if they are used less often. Understanding this difference between evolutionary time and historical change helps explain why certain aspects of human perception may appear quieter today than they once were in earlier human societies. When the pace of environmental change increases faster than biological evolution, an unusual situation can appear. the human body may still carry abilities shaped for older environments, even while daily life takes place in very different conditions. Evolution works slowly because it depends on small genetic changes spreading across many generations. The transformation of human environments during the last several thousand years has occurred far more quickly than this process. Agriculture, permanent settlements, cities, and later industrial technology all appeared within a relatively short period compared with the hundreds of thousands of years during which human sensory systems developed. As a result, many of the biological systems that helped early humans interpret natural landscapes remain present within the modern human body. The brain still reacts to sudden sounds, unexpected movement, or unfamiliar patterns in the environment. The senses remain capable of detecting subtle differences in sound, smell, and light. Yet the conditions that once required these abilities every day may no longer appear as frequently in modern environments. In earlier landscapes, survival often depended on recognizing small disturbances in the natural patterns of the environment. A brief silence among birds, a change in wind direction, or faint movement through vegetation could provide valuable information about nearby animals or other people. These signals formed a complex network of cues that early humans gradually learned to interpret. However, as societies developed agriculture and permanent settlements, daily survival began to depend more on cultivated resources and organized social systems. Instead of following animal tracks across large territories, many people began working within fields and villages where food sources were already known and controlled. This shift did not remove environmental awareness entirely, but it changed the kinds of signals that people needed to notice most often. Over time, social and technological signals began to occupy a larger role in human attention. Spoken language, gestures, and cooperation within communities became increasingly important forms of communication. Later, written language, tools, and structured work systems introduced additional layers of information that required attention. Human perception gradually adapted to these new forms of signals, while still retaining the sensory abilities shaped in earlier environments. The modern world continues this trend in even more complex ways. Digital technology, transportation systems, and artificial lighting create environments where information flows constantly through screens, devices, and social interaction. The brain remains highly active in processing these signals, often shifting attention rapidly between multiple sources of information. Yet these signals differ from those that once guided human movement through forests or grasslands. Instead of interpreting subtle patterns in wind, sound, and animal behavior, many people now interpret patterns in language, images, and technological alerts. The nervous system has adapted remarkably well to these changes because the human brain is flexible and capable of learning new forms of information. However, flexibility does not mean that earlier sensory systems disappear. The structures that evolved over long periods of human history continue to exist beneath these newer layers of perception. They still respond when unexpected sounds occur, or when movement appears suddenly within the environment. Many people have experienced moments when they become aware of a subtle change around them without immediately understanding the cause. A person might pause briefly after hearing a faint noise behind them, or feel a sense of attention rising when entering an unfamiliar place. These reactions often reflect the same biological systems that helped early humans remain aware of their surroundings. The difference is that modern environments rarely require constant interpretation of natural cues in order to survive. Food, shelter, and safety are often provided by social structures and technology rather than by direct observation of the landscape. When an ability is no longer required regularly, people may gradually rely on it less in everyday life. The ability itself remains present within the body, but it becomes less central to daily behavior. Over generations, this shift can create the impression that certain ancient abilities have faded, even though the biological foundations that once supported them still remain within the human nervous system. When abilities shaped by long periods of evolution meet environments that change rapidly, the results are often subtle rather than dramatic. The body does not suddenly lose the systems that once helped humans respond to natural landscapes. Instead, those systems may simply become less visible in daily life. They remain present within the nervous system, waiting quietly in the background, even when the modern environment rarely calls upon them. This situation can be compared to a tool that was once used every day but is now needed only occasionally. The tool still exists and works as it always did, yet people may forget about it because their routine no longer requires it. Human sensory awareness may have followed a similar path. For thousands of generations, subtle signals from the environment played an important role in guiding human attention. Wind patterns, distant sounds, the movement of animals, and changes in the behavior of birds all formed part of the information humans used to understand their surroundings. When environments shifted towards settlements, agriculture, and eventually cities, many of these signals became less central to everyday survival. The brain still carries the ability to detect them, but the environment now provides different types of information that compete for attention. Over time, this shift may influence how individuals experience their surroundings. Some people may rarely notice subtle changes in natural environments simply because their daily routines do not require it. Others who spend more time outdoors may remain more familiar with these signals because their activities bring them into closer contact with landscapes where such cues still appear. This difference does not necessarily reflect a change in the basic biology of the human brain. Instead, it reflects the interaction between biological abilities and the environments in which people live. The brain is capable of many forms of perception, yet the signals it learns to prioritize depend largely on experience. When attention is repeatedly directed towards certain types of information, those signals become easier to recognize. When signals appear less often, they may fade into the background of awareness. In this way, the modern environment may have gradually shifted the focus of human perception. The skills that help people navigate social systems, written information, and digital technology have become increasingly important. These skills require attention, memory, and pattern recognition, just as environmental awareness once did. Yet they operate within very different contexts from those that shaped early human life. The natural landscapes that once surrounded human communities have not disappeared entirely, but many people encounter them less frequently than earlier generations did. As a result, the sensory systems that evolved to interpret those landscapes may appear quieter or less practiced in everyday life. This does not mean that the ancient connection between human perception and the environment has vanished. Many individuals still experience moments when subtle cues draw their attention unexpectedly. A faint sound in a quiet forest, the sudden silence of birds, or the movement of animals at the edge of vision can still produce a quick shift in awareness. In such moments, the ancient sensory systems of the human brain briefly become visible again. These experiences suggest that the underlying abilities remain part of human biology even when they are rarely used. The human nervous system continues to carry the structures shaped by long interaction with natural environments. What has changed most dramatically is not the brain itself, but the landscapes in which that brain now operates. When environments evolve faster than biology, abilities that once shaped everyday survival may become quieter features of the human mind, still present but often hidden beneath the patterns of modern life. In the modern world, the environments surrounding many people are filled with forms of sound and light that did not exist for most of human history. These changes may appear ordinary today because they have become part of daily life, yet from the perspective of human evolution they are very recent. For tens of thousands of years, human senses developed in landscapes where darkness arrived naturally at sunset and where most sounds came from wind, animals, water, and human voices. The night sky provided faint illumination from the moon and stars, while the ground and surrounding vegetation produced subtle patterns of sound that could change from moment to moment. In contrast, modern environments often replace these natural signals with artificial ones. Electric lighting now fills many spaces with constant brightness long after sunset. Streets, buildings, and homes remain illuminated through much of the night, reducing the deep darkness that once shaped human perception after evening. At the same time, many cities and towns produce continuous background noise created by engines, machinery, and electrical systems. These sounds may seem quiet enough to ignore, yet they form a steady layer of noise that rarely disappears completely. When a background signal remains constant, the brain gradually learns to filter it out so that it no longer demands attention. This filtering process allows people to sleep through the sound of a fan or ignore the steady hum of distant traffic. However, it also means that subtle changes within those environments may become harder to notice because the brain treats the background as unimportant information. In natural landscapes, background sounds often change slowly over time. Wind rises and falls. Insects become louder during warm evenings and quieter when temperatures drop. Birds may produce sudden calls that interrupt the usual rhythm of the environment. These changes create patterns that the brain can learn and interpret. When one of those patterns shifts suddenly, attention often rises automatically because the change may signal something important. In modern environments, many sounds are produced by machines that operate with regular rhythms and constant intensity. Engines run at steady speeds. Electrical systems generate uniform humming tones. Traffic may continue through the night without long periods of silence. Because these signals remain stable, the brain may treat them as predictable and gradually reduce its sensitivity to them. Over time, this process may influence how people experience quietness itself. True silence is now rare in many urban areas. Even during the night, faint mechanical sounds often remain present in the background. When silence does appear, it may feel unfamiliar rather than ordinary. For most of human history, however, quiet environments were common, especially after dark. In such settings, even a faint sound could stand out clearly against the surrounding stillness. Artificial lighting also influences how humans interpret the environment. When landscapes remain illuminated through the night, the contrast between day and night becomes less dramatic. Early humans experienced a gradual transition from daylight to darkness that changed how they relied on different senses. As light faded, hearing and other senses became more important in understanding what was happening nearby. In brightly lit environments, vision remains dominant for much longer periods, and the brain may rely less on other sensory cues. These differences do not mean that modern humans have lost their sensory abilities. The ears, eyes, and nervous system remain capable of detecting subtle signals. Yet, the types of signals that reach those senses have changed. Instead of interpreting the shifting patterns of wind, animals, and natural darkness, the brain often processes artificial light and steady mechanical sound. The sensory systems shaped across long evolutionary periods now operate within environments that are structured very differently from the landscapes in which they first developed. This contrast between ancient sensory design and modern surroundings may help explain why certain subtle forms of awareness appear less common today. The human nervous system still carries the biological foundations that once allowed our ancestors to respond to small environmental changes. However, when the modern sensory world replaces many of the signals that once guided human attention, those ancient responses may become quieter features of perception, appearing only occasionally when the environment becomes still enough for them to emerge again. In environments filled with constant sound and light, the human brain gradually adapts in ways that help people continue their daily lives without becoming overwhelmed by sensory information. One of the most important abilities of the brain is its capacity to filter signals. Every moment, the senses deliver enormous amounts of data from the surrounding world. If the brain attempted to analyze every sound, every movement, and every change in light equally, attention would quickly become exhausted. Instead, the nervous system sorts incoming signals into categories that help determine which ones deserve attention and which ones can safely remain in the background. This filtering process is not a sign of weakness in perception. It is an essential feature that allows people to function within complex environments. When a sound repeats continuously, such as the hum of an air conditioner or distant traffic, the brain gradually recognizes that the signal does not require action. Over time, the sound fades from conscious awareness even though the ears continue to receive it. The same process happens with many visual signals. A steady light source or a familiar pattern of movement in a room quickly becomes part of the background once the brain determines that it carries no immediate meaning. This ability helps people concentrate on tasks such as reading, speaking, or navigating busy spaces. However, the same filtering process can also influence how subtle environmental signals are perceived. In natural landscapes where humans once lived for most of their history, background signals rarely remained perfectly constant. Wind, animals, water, and insects produced sounds that rose and fell in rhythm with weather, temperature, and time of day. Because these signals changed often, the brain remained responsive to their variations. A slight interruption in the usual rhythm of insects or birds could stand out clearly because the background itself was dynamic. Attention would rise not because the sound was loud, but because the pattern had changed. In modern environments, many background signals remain steady for long periods. Machines often produce uniform sounds that do not vary in the same ways as natural sources. Lighting systems maintain consistent brightness regardless of the position of the sun or the phases of the moon. Climate control systems regulate temperature and airflow so that indoor environments feel stable throughout the day and night. When signals remain stable for long stretches of time, the brain becomes very efficient at ignoring them. This adaptation helps people avoid sensory overload, yet it also means that fewer subtle variations reach conscious awareness. Over months and years of living in such environments, attention may gradually shift towards signals that stand out more strongly, such as spoken language, alarms, or visual notifications from devices. These signals are designed specifically to attract attention, often through sudden sounds or bright flashes. In contrast, many natural environmental cues are much quieter and more gradual. The brain may notice them less often simply because they do not compete effectively with louder or more immediate signals. The shift is not a loss of ability but a change in priority. The sensory systems that once helped humans interpret the movement of animals or the direction of wind still exist within the nervous system. Yet the brain must constantly decide which signals deserve its limited attention. In environments where artificial signals dominate, attention naturally adapts to them. The quiet language of natural landscapes becomes less familiar because it appears less often within everyday experience. At the same time, certain individuals may remain more responsive to subtle cues if their daily lives still include frequent contact with quieter environments. People who spend long periods in forests, deserts, mountains, or open water often report noticing small changes in sound, light, or movement more easily than those who live primarily in dense urban areas. This difference does not require extraordinary senses. Instead, it reflects the brain's ability to adjust its patterns of attention according to the signals that appear most frequently in a person's surroundings. The human nervous system remains flexible enough to interpret both natural and artificial environments. Yet the signals that dominate modern life may guide attention in directions that differ from those that shaped human perception across most of our species' history. When environments become filled with constant artificial signals, people may gradually lose familiarity with the quieter forms of information that once shaped human awareness. This shift often happens so slowly that it is rarely noticed directly. The brain simply adapts to the signals it encounters most often. Over time, attention becomes trained to respond quickly to the kinds of sounds, lights, and movements that dominate daily life. In modern settings, these signals often come from machines, electronic devices, or social activity rather than from the natural landscape. Phones vibrate or produce brief tones that immediately draw attention. Screens display visual alerts designed to stand out from surrounding information. Traffic sounds repeat through the day and night with predictable patterns. Each of these signals is created specifically to capture human attention quickly. Because they appear frequently, the brain becomes highly practiced at detecting them. In contrast, many signals from natural environments are quieter and more gradual. The movement of wind through trees may change slowly over time. Animal sounds may appear briefly and then disappear again. Shifts in temperature or air pressure often develop across hours rather than seconds. These signals can still be detected by the human senses, yet they do not compete easily with louder or more immediate stimuli. As a result, the brain may give them less priority unless a person spends time in places where those signals become important again. This difference helps explain why many individuals notice subtle environmental cues more clearly when they spend extended periods in quiet, natural settings. A person who visits a forest after living in a busy city may initially experience the environment as unusually still. After some time, however, the brain begins to recognize layers of sound that were not obvious at first. Insects, birds, and distant movement gradually form patterns that become easier to distinguish. The environment may begin to feel more detailed as the brain adapts to signals that were previously hidden beneath constant background noise. This adjustment does not involve the sudden development of new abilities. Instead, it reflects the brain returning attention to signals that it has always been capable of detecting. Many sensory abilities remain present, even when they are not used regularly. When the environment becomes quiet enough, those abilities may reappear naturally as the brain learns once again how to interpret subtle patterns. Over long stretches of human history, this quiet sensitivity to environmental changes likely formed part of ordinary perception. people moved through landscapes where wind, animals, water, and weather produced continuous signals that required interpretation. The brain became skilled at distinguishing which of those signals indicated meaningful changes. Yet as human environments shifted towards cities, machines, and artificial light, the signals reaching the senses changed as well. Instead of interpreting natural patterns, many individuals now interpret signals created by technology and social systems. These signals often demand faster and more frequent responses than those produced by natural landscapes. The brain adapts by directing attention toward the information that appears most relevant within daily life. However, beneath this adaptation, the deeper sensory systems shaped by earlier environments remain present. The human nervous system still contains the structures that evolved to detect subtle disturbances in sound, movement, and rhythm. These systems may simply be used less often in modern surroundings. When they are activated again, perhaps during a quiet walk through a forest or while listening carefully in a silent place, they can reveal a form of awareness that has accompanied humans throughout most of their history. The difference between past and present may therefore lie not in the disappearance of these abilities, but in the changing environments that determine how often they are needed. Although the human brain shares many common structures across all individuals, people do not experience the surrounding world in exactly the same way. Even when standing in the same place and listening to the same environment, different individuals may notice different details. One person may hear a faint sound in the distance that others ignore. Another may notice a subtle movement across the landscape that escapes the attention of those nearby. These differences are not unusual. They reflect the natural variation that exists within every human population. Just as people vary in height, strength, or eyesight, they also vary in how their brains process sensory information. Some individuals may have slightly greater sensitivity to certain sounds, while others may be quicker to notice changes in motion or patterns. Modern research in psychology and neuroscience shows that perception is shaped by both biology and experience. Each person's nervous system develops through a combination of inherited traits and environmental learning. Small genetic differences can influence how sensory systems function. For example, some people may detect particular sound frequencies more easily than others. Differences in attention, memory, and emotional responses can also influence how strongly someone reacts to certain environmental cues. These variations do not necessarily mean that one person possesses a special ability while another does not. Instead, they show that human perception exists across a range of sensitivities. At the same time, experience plays an equally important role in shaping awareness. The brain becomes skilled at interpreting the signals that appear most often in a person's daily life. Someone who spends years working in quiet natural environments may become very familiar with subtle sounds produced by wind, animals, or water. Another person who spends most of their time in busy urban spaces may become highly skilled at recognizing human voices within crowded noise, or noticing visual signals in complex surroundings. In both cases, the sensory system remains capable of detecting many different cues, but attention becomes specialized through repeated exposure. Anthropologists studying traditional societies have sometimes observed that individuals within the same community also differ in how strongly they notice environmental signals. Some people appear naturally attentive to small details in the landscape, while others rely more on social communication or shared observation within the group. These differences are not considered unusual within the community itself. Instead, they form part of the diversity that allows groups to function in flexible ways. One person may excel at tracking animals across large distances, while another may be particularly skilled at remembering locations of water sources or edible plants. Human societies have always benefited from this diversity of abilities. Biological variation therefore plays an important role in how individuals interact with their surroundings. Within any population, some people may possess sensory systems that respond more quickly to subtle changes in sound or movement. Others may require stronger signals before their attention shifts. These differences can remain small and often go unnoticed during everyday life. Yet when combined with certain environments or experiences, they may become more visible. For example, individuals who already possess strong sensitivity to sound may become especially aware of environmental signals if they spend long periods in quiet natural settings. In contrast, individuals whose attention is more strongly directed toward visual or social information may focus on different aspects of their surroundings. The key idea is that human perception does not operate as a single uniform system shared equally by everyone. Instead, it exists along a broad spectrum shaped by both biology and experience. Over long periods of time, this natural variation may help explain why certain individuals appear particularly responsive to subtle environmental cues. The ability itself is not entirely new. It grows from the same sensory systems that exist in all humans. What differs is how strongly those systems respond, and how often individuals encounter environments that encourage them to remain active. The differences between individuals become easier to understand when we consider how attention works inside the human brain. Attention is not a fixed ability that operates in exactly the same way for everyone. Instead, it behaves more like a shifting spotlight that can focus on certain signals while leaving others in the background. At any moment, the brain receives far more sensory information than it can consciously process. Sounds arrive from multiple directions, light enters the eyes from countless objects, and the body receives signals from movement, temperature, and internal processes. To manage this flow of information, the brain constantly decides where attention should be directed. This decision is influenced by many factors, including past experience, emotional responses, and expectations about the environment. Some people naturally direct more attention towards subtle sensory cues. They may notice faint sounds, small movements, or slight changes in atmosphere more quickly than others. These individuals are sometimes described in psychological research as having higher sensory sensitivity. This term does not mean that their senses are physically stronger in every way. Instead, it suggests that their brains respond more readily to incoming sensory signals. When the environment changes even slightly, their attention may shift more quickly. Other individuals may filter sensory information more strongly. Their brains focus primarily on signals that are clearly relevant to current tasks, allowing many background details to pass unnoticed. This style of perception can be useful in busy environments where too much attention to every sound or movement would become distracting. For example, people working in crowded urban spaces often learn to ignore large amounts of background noise so that they can concentrate on conversations or work activities. Both styles of attention have advantages depending on the situation. A person who is highly responsive to environmental cues may perform well in settings where subtle changes carry important information. Someone whose attention filters out background signals may function more comfortably in environments filled with constant stimulation. These differences illustrate how flexible the human brain can be. Perception is not simply determined by the strength of the senses themselves. It also depends on how the brain organizes and prioritizes the signals those senses receive. Modern neuroscience suggests that these patterns of attention are shaped partly by biological factors and partly by experience. Some individuals may be born with nervous systems that respond more strongly to sensory input. Others may develop greater sensitivity through years of exposure to certain environments. For instance, people who spend long periods in quiet natural landscapes often report becoming more aware of subtle sounds or movements over time. Their brains gradually adjust to environments where small signals carry useful meaning. Conversely, individuals who grow up in environments filled with constant stimulation may become more practiced at filtering sensory input so that they can focus on specific tasks. The brain adapts to the conditions it encounters most frequently. This adaptation occurs throughout life, but it may be especially strong during childhood when the brain is developing rapidly. Because of these differences, human perception does not operate as a single uniform system across all individuals. Instead, it reflects a wide range of sensitivities and attentional styles. Within any group of people, some individuals may be especially attentive to faint environmental signals, while others may rarely notice them. These variations do not represent errors in perception. They are natural expressions of the brain's flexibility. Over the long history of human evolution, such diversity may have helped communities function effectively in changing environments. Different individuals could respond to different types of information, increasing the chances that important signals would be noticed by someone within the group. When we consider this diversity of perception, it becomes easier to understand why certain people today may appear unusually sensitive to subtle changes in their surroundings. Their nervous systems may simply be tuned in ways that allow those ancient sensory pathways to remain more active than they are for others. When scientists study human perception across different cultures and environments, they often observe that the brain's abilities do not disappear simply because they are used less often. Instead, these abilities may remain present in a quieter form, becoming visible again when the environment encourages them. This idea can be seen in many everyday experiences. A person who lives for years in a busy city may become accustomed to filtering out the constant sound of traffic and machinery. When that same person spends time in a quiet, natural setting, the change can feel surprising. At first, the silence may seem unusual, almost empty. Yet after some time, the environment begins to reveal layers of sound that were not obvious before. The wind moving through leaves, distant birds, insects hidden in grass, or the movement of small animals gradually become easier to notice. Nothing in the human body has changed during this short period. The ears have not suddenly grown more sensitive. Instead, the brain has begun paying attention to signals that were previously masked by louder sounds. This shift illustrates an important feature of human perception. Many sensory abilities remain present even when they are rarely used. The brain simply adjusts its patterns of attention according to the signals that appear most often in daily life. Anthropologists studying communities that maintain close relationships with natural landscapes sometimes describe similar patterns. People who grow up in environments where hunting, gathering, or traveling through large territories remain common often become highly familiar with subtle environmental cues. They may recognize faint animal tracks in soil, hear distant movements across open land, or notice small changes in weather conditions. These skills do not necessarily reflect extraordinary biological differences from other humans. Instead, they develop through long experience within environments where such signals are meaningful. Children raised in these settings gradually learn to interpret patterns in sound, movement, and landscape as part of ordinary daily life. The brain becomes practiced at recognizing these cues because they appear frequently. In other environments where daily activities depend more on social communication or technology, attention naturally shifts toward different types of information. People become skilled at interpreting spoken language, written symbols, digital messages, and complex social interactions. These abilities also require advanced perception and memory, yet they focus on different signals than those present in natural landscapes. The human brain remains capable of both forms of awareness, but it strengthens the abilities that match the surrounding environment. This understanding helps explain why certain individuals today may appear to possess an unusually strong awareness of subtle environmental cues. In many cases, the difference arises not from rare biological traits, but from the combination of natural variation and repeated experience. Someone who spends long periods in quiet, natural settings may gradually reactivate sensory pathways that remain present in all humans. Their attention becomes more sensitive to changes in sound, light, and movement simply because those signals become relevant again. Others who live primarily in environments dominated by artificial signals may rarely encounter situations where such sensitivity is required. Over time, the brain organizes its priorities around the information that appears most frequently. The ancient sensory systems shaped across most of human history remain part of the nervous system, yet they may operate quietly beneath layers of modern attention. When conditions change and the environment becomes still enough, those older patterns of perception can sometimes emerge again, reminding us that the human mind still carries traces of the landscapes in which our species first learned to observe the world. For much of human history, survival rarely depended on a single individual acting alone. Early human groups lived and moved together across landscapes that could be unpredictable and sometimes dangerous. Because of this, awareness of the environment often functioned as a shared activity rather than an isolated ability. When a group traveled across open land or rested near a temporary camp, different individuals naturally noticed different details in the surroundings. One person might hear a distant sound and pause. Another might notice movement near the edge of the landscape. Someone else might recognize a familiar smell carried by the wind. These small observations, when combined, created a collective understanding of what was happening around the group. Anthropologists studying traditional human societies have often described how this shared awareness helped groups respond to changes in their environment. Instead of relying entirely on one person to detect danger or opportunity, information emerged through the combined perceptions of several individuals. A faint sound noticed by one person might cause others to become alert. Someone who had experience with animal behavior might interpret the meaning of that sound. In this way, environmental awareness spread through the group as people responded to each other's attention. This cooperative form of perception may have been especially valuable in landscapes where visibility was limited. Dense vegetation, uneven terrain, and shifting weather could hide important signals from any single point of view. A group of individuals observing from different positions increased the chances that subtle changes in the environment would be noticed. Even when a signal was weak or uncertain, the reaction of one person could guide the attention of others. The group as a whole, therefore, became more aware than any single individual might have been alone. This pattern of shared attention appears in many aspects of human behavior. When people move together through unfamiliar environments, they often watch each other for cues about where to look or how to respond. If one person suddenly stops walking and turns their head, others may quickly follow the same direction of attention. The brain is highly sensitive to these social signals because human survival has long depended on cooperation. Awareness spreads quickly within groups because people naturally observe the reactions of those around them. In earlier human societies, this process may have helped distribute environmental awareness across entire communities. Not everyone needed to possess exactly the same level of sensitivity to every signal. Instead, variation among individuals could become an advantage. Some members of a group might notice faint sounds more easily, while others might be skilled at interpreting animal tracks or changes in weather. Together, these different abilities formed a network of perception that strengthened the group's ability to understand its surroundings. This collective awareness did not require constant discussion or formal organization. Much of it likely occurred through quiet observation and subtle responses. A person who became alert might shift posture, slow their movement, or direct their gaze toward a particular location. These small actions could guide the attention of others without the need for words. Over time, such patterns of shared attention became part of the natural rhythm of group life. Modern environments often reduce the need for this kind of collective environmental awareness. Technology, infrastructure, and organized systems provide many forms of safety that once depended on direct observation of the landscape. Yet the human brain still carries the social sensitivity that allows attention to spread through groups. People continue to watch each other for cues about where to look and how to respond, even in settings very different from those faced by early humans. This social dimension of awareness reminds us that the abilities shaped across human history were rarely meant to operate in isolation. They developed within communities where perception, attention, and understanding were shared across many individuals moving together through the same environment. When awareness is shared within a group, the role of each individual does not need to be identical. Human communities have always contained a wide range of personalities, temperaments, and perceptual styles. Some people naturally remain calm and observant for long periods, quietly watching the surrounding environment. Others focus more strongly on social interaction, conversation, or the organization of daily tasks. Within early human groups, these differences may have helped distribute attention across many forms of information at the same time. A person who spent time observing the landscape might notice distant movement that others overlooked. Someone else might remember the location of water sources or seasonal plants. Another individual might pay closer attention to the emotional tone of the group, helping maintain cooperation and communication. Each of these roles supported survival in different ways. The human brain appears to be well suited for this kind of diversity. Instead of forcing every individual to interpret the world in exactly the same way, evolution allowed a range of perceptual tendencies to exist within the population. This diversity may have increased the chances that important signals would be noticed by someone. When one person's attention responded to a change in the environment, others could quickly follow that reaction and share the information. In quiet landscapes where small signals carried meaning, even a brief pause or shift in posture might guide the awareness of nearby people. Because humans are highly social beings, attention often spreads through observation of others. When someone suddenly becomes alert, those nearby instinctively look in the same direction. This behavior appears even in modern environments. A group of people standing together may quickly turn their heads if one person reacts to a sudden sound. The brain is sensitive to these social cues because they once played an important role in helping communities respond to the environment as a coordinated group. In earlier human societies, communication was not limited to spoken language. Subtle movements, gestures, and changes in behavior often carried important information. A hunter who noticed faint animal tracks might slow down or point quietly toward the ground. Others nearby could then examine the same signs and add their own observations. Through this process, knowledge about the environment spread across the group without requiring long explanations. Over time, such patterns of shared attention may have created a form of collective awareness that was stronger than any individual perception alone. Even when signals were weak or uncertain, the combined observations of several people could produce a clearer understanding of the situation. One person might hear a distant sound, another might notice birds moving suddenly, and a third might recognize the smell of animals carried by the wind. Together, these small pieces of information formed a larger picture of what was happening in the landscape. In this way, the abilities of individuals blended into a cooperative system of perception. Modern environments often reduce the need for such shared environmental awareness because many risks are managed through technology and organized systems. Roads, buildings, lighting, and communication networks provide forms of safety that once depended on constant observation of the natural world. Yet the social mechanisms that spread attention within groups remain deeply rooted in human behavior. People still rely on each other's reactions to interpret uncertain situations. A sudden movement in a crowd, a shift in tone during conversation, or the alert posture of another person can still guide attention quickly. These patterns remind us that human perception has always existed within a social context. The awareness that helped early humans survive did not belong to isolated individuals alone. It emerged from communities where many people contributed their observations, allowing the group as a whole to remain attentive to changes in the surrounding environment. When awareness spreads through a group, the environment is no longer interpreted by a single mind, but by many minds working quietly together. Each individual contributes small pieces of information gathered through their own senses and experiences. Over time, these fragments combine into a broader understanding of the landscape. Early human communities likely depended on this shared perception more often than we might imagine today. Movement across unfamiliar terrain, the search for food, and the need to remain alert to predators or rival groups all required attention that extended beyond any one person. In such situations, the reactions of others could become valuable signals in themselves. A sudden pause, a change in walking rhythm, or the direction of someone's gaze might quietly guide the attention of the entire group. The brain is well suited to recognize these cues because humans evolved within highly social environments where observing others was essential for survival. Even today, people instinctively watch the behavior of those around them when something unexpected occurs. If several individuals begin looking toward the same location, others nearby often follow without needing an explanation. This response appears so quickly that it often happens before conscious thought has time to form. In earlier landscapes where visibility could be limited by vegetation, darkness, or distance, such social cues may have played a powerful role in helping groups remain aware of their surroundings. When one person noticed a subtle change in the environment, the resulting shift in posture or attention could spread through the group within seconds. Awareness therefore traveled across the community, much like a ripple across water. In this sense, the ability to notice small environmental signals was not only a property of individual perception, but also a feature of group behavior. The collective sensitivity of the group could become stronger than that of any single person because many observers were present at once. Differences between individuals added strength to this system. Some people might respond quickly to faint sounds, while others might be more attentive to movement across open ground. Another person might recognize patterns in animal behavior or the smell of approaching weather. These variations allowed the group to cover a wider range of environmental signals. Instead of everyone paying attention to exactly the same cues, the community naturally distributed attention across many forms of information. In quiet landscapes, this cooperative awareness may have helped human groups move with remarkable sensitivity to their surroundings. The group did not need constant conversation or instructions. Small reactions from one person could guide the focus of others, allowing attention to shift smoothly through the community. The landscape, the senses, and the social behavior of the group became connected parts of a single system of awareness. In modern societies, many aspects of daily life no longer depend on such collective environmental perception. Buildings, vehicles, and communication technology often replaced the need for direct observation of the landscape. Yet the underlying social mechanisms remain deeply embedded within human behavior. People still respond to each other's reactions when interpreting uncertain situations. A crowd may suddenly grow quiet when someone notices something unusual. Individuals often look toward the same direction when others show curiosity or concern. These patterns suggest that the ancient link between perception and social cooperation continues to shape human awareness, even within environments very different from those of early human history. Understanding this connection helps illuminate how certain forms of environmental sensitivity may persist today. The ancient ability suggested in the title may not belong entirely to rare individuals acting alone. Instead, it may reflect a deeper human capacity that becomes most visible when people and environments allow attention to spread gently through shared observation. Across most of human history, the relationship between people and their surroundings remained close and continuous. Human groups moved across landscapes where daily survival depended on observing the patterns of the natural world. Water sources, animal migrations, seasonal plants, and changes in weather all influenced where people traveled and how they organized their lives. Because of this, awareness of the environment was not a special activity that occurred only at certain moments. It formed a quiet background to nearly everything humans did. People learned the rhythms of the places where they lived in the same way they learned the habits of those around them. The landscape itself became familiar through repeated experience. Paths across open ground, the shape of distant hills, and the location of trees or rivers slowly formed a mental map inside the mind. Over time, individuals could move through these landscapes with a sense of orientation that came not only from sight, but also from memory and expectation. This type of awareness did not require constant concentration. Instead, it functioned as a steady connection between the brain and the surrounding world. The mind continuously compared the present moment with patterns learned through past experience. If the environment behaved as expected, attention remained calm and relaxed. When something differed from those patterns, awareness naturally increased. For example, the sudden absence of familiar sounds might draw attention, or an unexpected movement across the landscape might prompt someone to pause. These reactions were not dramatic or exaggerated. They were quiet adjustments in attention that help people remain aware of their surroundings while continuing their daily activities. Archaeological research suggests that early human groups often returned to the same territories repeatedly across generations. Certain valleys, rivers, or coastal areas provided reliable access to water, animals, and edible plants. As a result, the knowledge of these landscapes accumulated gradually within communities. Older members of a group carried memories of seasons, migration patterns, and safe routes across difficult terrain. Younger members learned these patterns by observing and participating in daily life. Over time, the landscape itself became part of the shared memory of the group. When people moved through familiar areas, they carried this memory with them. The environment was not experienced as an unknown space, but as a place filled with meaning shaped by long experience. Modern environments often function differently. Many people move through cities and buildings that change frequently as construction, transportation, and technology reshape the landscape. Streets are redesigned, buildings appear and disappear, and digital navigation tools provide directions that once depended on memory and observation. These changes allow people to travel efficiently across large distances, yet they also reduce the need to build detailed mental maps of the environment. Instead of relying on long familiarity with a place, individuals may depend more on external systems, such as signs, maps, or electronic devices. The brain still possesses the ability to form strong spatial memories, but it may be used differently than it was in earlier human societies. When daily movement occurs through spaces designed primarily for transportation and work, the environment may feel more temporary and less deeply known. The quiet relationship between memory and landscape that once shaped human awareness may appear less often in everyday life. Yet the ability itself remains part of the human mind. When people spend extended time in the same natural environments, walking the same trails, observing the same trees, or returning to the same quiet places, they often rediscover how quickly the brain begins to recognize patterns in the landscape. Subtle changes in sound, light, or movement become easier to notice because the mind has learned what the environment normally feels like. In this way, The ancient connection between memory and landscape continues to exist beneath the surface of modern experience, waiting for conditions that allow it to appear again. As people spend time in the same environment repeatedly, the brain begins to build a detailed internal representation of that place. This process happens gradually and often without conscious effort. Each walk through a familiar path adds small pieces of information to memory. The position of rocks along a trail, the shape of tree branches against the sky, and the sound of water flowing nearby slowly become part of a mental map. Over time, the brain learns not only where things are located, but also how the environment normally behaves. Morning light may reach certain areas earlier than others. Wind may move more strongly through open ground than through dense vegetation. Animals may appear along particular routes at predictable times of day. When these patterns repeat often enough, they form expectations within the mind. The brain quietly anticipates how the landscape should look, sound, and feel. This expectation allows people to notice subtle changes that might otherwise remain invisible. A fallen branch across a path, an unfamiliar scent in the air, or a silence where birds usually call can stand out clearly because the mind already knows the usual pattern of the place. Neuroscience research has shown that certain regions of the human brain play an important role in forming these internal maps. One well-studied area is the hippocampus, which helps organize spatial memory and navigation. This structure allows individuals to remember locations, recognize landmarks, and understand how different parts of an environment connect to one another. The hippocampus works together with other parts of the brain that process visual information, sound, and movement. Through repeated experience, these systems cooperate to create a stable representation of the surrounding landscape. In natural environments where early humans lived for most of their history, this mapping ability likely played a central role in daily life. People traveled across territories that contained many important locations, including water sources, seasonal plants, animal habitats, and safe places to rest. Remembering these places required not only recognizing their positions, but also understanding how they related to one another across distance. Paths across valleys, hills, rivers, or forests gradually formed networks of movement that existed in the memory of the community. Individuals who knew these routes well could guide others through unfamiliar terrain or return to important locations after long journeys. These internal maps also helped people detect when something in the environment had changed. Because the brain stored detailed expectations about familiar places, even small differences could draw attention. A new trail through vegetation might suggest that animals had passed recently. A change in water level could indicate shifting weather patterns. The landscape itself, therefore, communicated information through comparison with memory. Modern environments often reduce the need to rely on such internal mapping. Navigation systems, street signs, and digital maps allow people to travel without building strong spatial memories of the areas they visit. Many individuals move quickly through cities using vehicles or transportation networks that emphasize speed rather than observation. As a result, the brain may form fewer detailed expectations about the surrounding landscape. Places can feel interchangeable because attention focuses more on destinations than on the environment between them. Yet the brain still retains the same capacity to build internal maps whenever conditions allow. When people spend time moving slowly through the same natural areas, the mind begins to reconstruct this relationship between memory and landscape. The position of landmarks becomes familiar, the rhythm of sound and light begins to repeat, and the environment gradually develops a sense of pattern. Through this process, awareness of subtle changes can return naturally, not because a new ability has appeared, but because the brain has once again learned what the environment normally feels like. When a landscape becomes familiar through repeated experience, awareness of that place begins to operate in a quiet and almost effortless way. The brain no longer needs to study every detail deliberately because many features of the environment have already been learned. Paths, landmarks, and sounds settle into memory and become part of an internal expectation about how the surroundings normally behave. In this state of familiarity, attention can remain relaxed while the mind continues to monitor the environment gently in the background. This form of awareness is sometimes described as a balance between memory and perception. Memory provides a stable image of the place, while perception compares the present moment with that stored image. As long as the two remain consistent, the environment feels predictable and calm. When something changes, however, The difference may appear immediately because it does not match the familiar pattern. A rock that was not present before, a shift in the usual direction of wind, or the sudden absence of animal sounds may draw quiet attention even before a person consciously understands why. The brain recognizes the difference because it already knows the usual rhythm of the place. For early human communities, this kind of awareness may have developed naturally over long periods of living within the same territories. Groups often moved seasonally, but returned repeatedly to landscapes they knew well. The memory of these places accumulated across years and sometimes across generations. Knowledge of terrain, water sources, and animal behavior gradually formed a deep understanding of how each location behaved across time. People did not need to examine every part of the environment constantly. Instead, they moved through landscapes where familiarity allowed subtle differences to stand out more clearly. The quiet awareness created by this familiarity may have been one of the ways humans remained attentive to their surroundings without exhausting their attention. Because the brain already recognized most elements of the environment, it could respond quickly when something unusual appeared. This ability did not depend on extraordinary senses. It depended on the relationship between memory and repeated experience in the same place. Modern life often interrupts this process because many people move frequently between different environments. Travel, work, and technology allow individuals to shift quickly from one location to another. The mind may not spend enough time in a single landscape to build the deep familiarity that once developed naturally through daily life. Instead of forming detailed internal expectations about a place, people often rely on signs, digital navigation, or structured paths designed by others. These tools allow movement through unfamiliar spaces but do not always create the same long-term relationship between memory and environment. Yet when individuals return to a place repeatedly, even in the modern world, the same ancient pattern can begin to appear again. A forest path walked many times becomes recognizable even in dim light. The pattern of birds or insects begins to feel familiar. Changes in weather or sound become easier to notice because the brain has learned what usually happens there. Through repetition, the environment gradually becomes part of the mind's internal map. This process reveals something important about the ability suggested in the title. The awareness that once helped humans notice subtle changes in the landscape may not be an extraordinary skill possessed by only a few individuals. Instead, it may arise naturally when the brain develops deep familiarity with a place. When memory and perception work together in this way, the environment itself becomes easier to understand, and the quiet signals within it become visible again. If we look carefully at the long arc of human history, one pattern becomes clear. For nearly all the time our species has existed, human life unfolded inside environments where the boundary between people and the landscape was thin. Humans did not simply observe the natural world from a distance, they lived inside its rhythms. The cycles of daylight and darkness shaped when people moved, rested, and gathered together. Seasonal shifts influenced where communities traveled and what food they depended on. The sound of wind, the movement of animals, and the changing behavior of birds formed part of the information that people absorbed quietly each day. In such environments, the human brain learned to exist within a constant flow of subtle signals. Awareness did not require dramatic effort. It functioned more like a steady conversation between the senses and the landscape. Over generations, this conversation became part of the background structure of human life. People rarely stopped to think about it directly because it was woven into ordinary experience. The ground beneath their feet, the sky above them, and the movement of animals across the land all formed part of a shared environment that the brain gradually learned to interpret. Yet when we look at the present moment in human history, the relationship between people and their surroundings often appears very different. Large numbers of humans now live in environments where the landscape has been heavily shaped by human design. Cities concentrate millions of individuals into spaces where buildings, roads, and machines dominate the visual and acoustic environment. Instead of open terrain and natural patterns, many daily signals come from artificial lighting, mechanical sounds, and digital communication. The shift from natural landscapes to built environments happened very quickly when compared with the long evolutionary history of the human species. For tens of thousands of years, human perception developed in response to forests, grasslands, rivers, and coastlines. In contrast, Dense urban environments have existed for only a small fraction of that time. Because biological evolution moves slowly, the human nervous system has not fundamentally changed during this short period. The same sensory structures that helped early humans interpret natural landscapes still operate within modern environments today. What has changed most dramatically is the type of information that reaches those senses. Instead of subtle environmental patterns that unfold gradually across time, modern environments often present signals that are sharper, brighter, and more immediate. Screens display information that demands rapid attention. Traffic produces continuous mechanical sound. Artificial lighting allows activity to continue long after the sun has set. These signals guide human awareness in directions that differ from the landscapes in which our sensory systems originally developed. The brain remains capable of detecting quiet environmental cues, yet those cues may appear less frequently within everyday life. As a result, the ancient forms of awareness that once developed naturally through daily interaction with landscapes may now emerge only occasionally. A person walking through a quiet forest may suddenly notice how sensitive their hearing becomes. Someone spending time in open countryside may begin to recognize patterns in wind or animal behavior that previously passed unnoticed. In such moments, the human nervous system briefly reconnects with the kinds of signals that shaped perception across most of our species' history. These experiences suggest that the ancient sensory pathways of the human brain have not disappeared. Instead, they continue to exist beneath layers of modern attention, waiting for environments quiet enough to allow them to operate once again. When the human brain developed across long stretches of evolutionary time, it did so in environments where information arrived slowly and often quietly. Natural landscapes rarely produce the rapid bursts of stimulation that are common in many modern settings. Instead, signals unfolded gradually through patterns that repeated across days, seasons, and years. The rising and setting of the sun marked the beginning and end of activity. Animal movements followed seasonal routes that could be learned through observation. Changes in weather approached over hours or days rather than seconds. Within these rhythms, the brain learned to recognize patterns and to notice when those patterns shifted. Attention moved calmly between different sensory signals without needing to react constantly to sudden interruptions. In contrast, many modern environments present information at a much faster pace. Digital devices deliver messages and images instantly. Transportation systems move people quickly through unfamiliar landscapes. Artificial lighting extends activity late into the night, reducing the natural separation between day and darkness that once guided human routines. The brain has adapted to these changes with remarkable flexibility, yet this adaptation often requires attention to shift rapidly from one signal to another. Instead of observing gradual changes in the environment, people may respond to frequent alerts, notifications, or visual messages that demand immediate awareness. This difference in pace can influence how perception operates. When signals appear quickly and repeatedly, the brain must filter information aggressively in order to prevent overload. Many details are ignored so that attention can remain focused on tasks that require immediate action. This filtering helps people function efficiently in busy environments, yet it may also reduce the opportunity to notice quieter signals that develop slowly. Subtle changes in sound, light, or movement can pass unnoticed, simply because attention is directed elsewhere. In landscapes where early humans lived for most of their history, the slower pace of environmental change allowed perception to unfold differently. When a person walked across open ground or through a forest, the environment revealed itself gradually. Wind shifted direction across the land, animals moved through vegetation, and distant sounds carried across large spaces. Because these signals changed slowly, the brain had time to observe and compare them with previous experiences. Awareness could remain broad rather than narrowly focused. People could listen quietly to the environment without needing to respond immediately to constant interruptions. Anthropologists who have studied communities living close to natural landscapes often describe this style of attention as patient observation. It does not rely on intense concentration but on a calm openness to the surrounding world. Over time, the brain becomes familiar with the patterns of the place, allowing even small differences to stand out gently within awareness. A faint sound may attract notice because the environment is otherwise quiet. A slight change in the movement of birds may signal a shift in animal activity. These signals rarely demand immediate action, yet they form part of a broader understanding of the landscape. When environments become quieter and slower, the brain may rediscover this older rhythm of perception. Individuals who spend extended time away from constant stimulation often describe how their attention gradually expands. Sounds that once seemed insignificant begin to feel clearer. The environment reveals patterns that were previously hidden beneath faster signals. These experiences suggest that the ancient sensory systems shaped during human evolution continue to function beneath the surface of modern life. They simply require conditions where the pace of information allows the brain to observe rather than constantly react. When the pace of information slows and the environment becomes quiet enough, something interesting often happens in the human mind. Attention begins to expand rather than narrow. Instead of reacting quickly to sudden signals, the brain gradually becomes aware of patterns that unfold gently across the surrounding landscape. Sounds that once blended together begin to separate into distinct layers. A distant bird call may appear against the background of wind moving through trees. The movement of leaves may reveal the direction of air across open ground. Even small variations in light or shadow may begin to feel meaningful once the eyes have time to adjust to the rhythm of the place. These experiences suggest that human perception is capable of operating in more than one mode. In fast and busy environments, attention becomes selective and narrow because the brain must choose which signals deserve priority. In slower environments, awareness can remain broader, quietly observing many details at once without needing to react immediately. Both forms of perception are useful depending on the circumstances. The modern world often requires rapid decisions and constant attention to communication, technology, and social interaction. Yet the broader form of awareness shaped across most of human history still remains possible when the environment allows it to emerge. This broader awareness does not feel dramatic or extraordinary. Instead, it often feels calm and steady, as if the mind is gently connected to the surrounding world. The senses continue receiving information, but the brain processes it without urgency. Many people notice this shift when they spend long periods in quiet natural settings such as forests, mountains, deserts, or open water. At first the mind may remain restless, still expecting the quick signals that dominate everyday life. After some time, however, attention begins to slow. The environment reveals patterns that were previously hidden beneath faster forms of stimulation. The call of birds may repeat at intervals that follow invisible rhythms. The sound of wind may move across the landscape in waves that become easier to recognize. In such moments, the brain seems to remember an older style of perception that developed long before modern technology reshaped the human sensory world. This experience does not require rare biological traits. It emerges naturally from the interaction between the human nervous system and the environment in which that system evolved. For most of human history, people lived within landscapes where information arrived slowly enough for the brain to observe these patterns continuously. The senses learned to interpret the quiet language of the environment because it formed part of everyday survival. Over many generations, this ability became part of the natural design of human perception. In the modern world, where signals often arrive quickly and in large numbers, this older rhythm of awareness may appear less often. Yet the nervous system that once supported it remains present within every human being. When the environment becomes quiet enough and the pace of information slows, the mind can rediscover how to listen again. The ancient sensitivity suggested by the title may therefore not belong only to a small number of people who possess an unusual gift. It may instead represent a capacity that still exists within the human brain, waiting for the conditions that allow it to awaken. As the long history of human perception comes into view, a quiet pattern begins to appear. The abilities that once helped humans remain aware of their surroundings were never meant to stand apart from the environments in which people lived. They emerged gradually from the relationship between the brain and the landscape. Over thousands of generations, human senses learned to respond to patterns in wind, sound, movement, and light. These patterns were not extraordinary or mysterious. They formed part of the everyday rhythm of life in natural environments where survival depended on understanding subtle changes in the world. When early humans walked across open ground, rested beside water, or moved through forests, their senses were constantly receiving information from the landscape. Most of this information was quiet and repetitive. Birds called in familiar patterns, insects created steady background sound, and wind moved through vegetation in ways that repeated from day to day. Because these signals appeared so often, the brain gradually learned their rhythms. Awareness became attuned to the difference between what was normal and what was unusual. A sudden silence among birds might attract attention. An unexpected movement across the ground might cause someone to pause and observe more carefully. These responses did not require conscious effort. They were part of the ordinary connection between the human nervous system and the environment. Yet when we look at modern life, it is easy to imagine that such sensitivity belongs only to a small number of individuals. Many people now live in environments where the signals that once shaped human awareness appear less frequently. Artificial lighting, constant mechanical sound, and digital communication dominate the sensory world of cities and towns. The quiet patterns of natural landscapes may appear only occasionally during travel or brief visits to quieter places. Because these signals are less familiar, the awareness they once supported may seem unusual or rare. This perception can create the impression that only a small percentage of people still possess the ancient ability suggested in the title. However, the history of human evolution suggests a different perspective. The sensory systems that helped our ancestors interpret natural landscapes remain present in the human brain today. The structure of the nervous system has not fundamentally changed during the short period in which modern environments developed. The ears still detect faint sounds. The eyes still recognize small movements across distance. The brain still compares the present moment with patterns stored in memory. What has changed most dramatically is the environment in which these systems now operate. When daily life rarely requires attention to subtle environmental cues, the brain naturally focuses on other forms of information that appear more frequently. This shift does not remove the older abilities from the nervous system. Instead, it allows them to rest quietly beneath the surface of modern attention. When conditions change and the environment becomes slower, quieter, and more familiar, those abilities may reappear without effort. A person walking through a landscape that they know well may suddenly notice small details that previously went unnoticed. The sound of distant animals, the direction of wind, or the movement of birds may form patterns that feel meaningful once again. These experiences suggest that the ancient awareness hinted at in the title may not belong exclusively to a rare group of people. Rather, it may represent a human capacity that has become less visible simply because the environments that once nurtured it have changed. When we return to the question suggested by the title, the idea that only a small percentage of humans still possess an ancient ability may begin to appear less mysterious than it first seemed. Throughout the long development of our species, human perception evolved within landscapes where attention to subtle patterns was part of everyday life. The senses were constantly receiving quiet information from wind, animals, vegetation, water, and changing weather. Over time, the brain became skilled at recognizing when these familiar patterns shifted. This sensitivity did not require special training or rare talent. It emerged naturally because the environment continuously provided the signals that the brain was designed to interpret. Yet when the conditions surrounding human life change, the expression of these abilities can change as well. In environments dominated by artificial light, mechanical sound, and rapid streams of digital information, attention often shifts towards signals that demand immediate response. Messages appear instantly on screens. Engines produce constant background noise. Artificial lighting reduces the contrast between day and night. In such settings, the quiet signals of the natural world may appear rarely enough that the brain no longer expects them as part of ordinary experience. When a skill is not required frequently, people may gradually forget that it exists. This does not mean the biological foundation of the ability has disappeared. It simply means that the environment no longer calls upon it as often. The idea that only a small percentage of people still show strong sensitivity to subtle environmental cues may therefore reflect differences in daily experience, rather than permanent biological change. Some individuals continue to spend large amounts of time in landscapes where quiet patterns remain visible. People who work outdoors, travel through forests or mountains, or live in areas where natural sound and darkness still shape daily life, may remain more familiar with these signals. Their brains continue practicing the interpretation of subtle environmental changes because those changes remain relevant within their surroundings. Others who spend most of their time in densely built environments may rarely encounter the same conditions. Their attention becomes highly skilled at interpreting social communication, digital information, and the complex signals of modern technology. These abilities are equally remarkable, yet they direct awareness toward different aspects of the world. Over time, this difference in experience can create the impression that only a few individuals still carry the ancient sensitivity that once belonged to all humans. The truth may be quieter and more ordinary. The nervous system that allowed early humans to notice subtle environmental patterns continues to exist within modern people. What differs is the environment in which that nervous system operates and the signals it encounters most frequently. When people return to quieter places where natural patterns unfold slowly, many discover that their perception begins to change. Sounds become clearer, movements easier to notice, and the rhythm of the environment easier to understand. These moments suggest that the ancient connection between human awareness and the natural world has not vanished. Instead, it waits patiently within the structure of the human brain, ready to appear again whenever the surrounding world becomes quiet enough to be heard. As the story of human perception reaches its quiet conclusion, it becomes possible to look again at the idea that began this journey. The suggestion that only a small percentage of humans still possess an ancient ability may initially sound dramatic, almost as if a rare trait had survived from a distant past. Yet the deeper we look into the history of our species, the more ordinary the explanation becomes. The human brain did not evolve for cities, screens, engines, or artificial light. For nearly all the time that Homo sapiens has existed, people lived in landscapes where the signals guiding awareness came from the natural world itself. The movement of wind across grass, the behavior of animals, the rhythm of daylight and darkness, and the quiet sounds of insects and birds formed the background language of the environment. Within this language, human senses gradually learned how to recognize patterns. The brain compared the present moment with memories of how the landscape usually behaved. When something shifted from that pattern, attention naturally rose. This process did not belong to a special group of individuals. It belonged to the design of the human nervous system itself. Every person carried the biological structures needed to interpret these subtle signals, because those structures had been shaped across thousands of generations of life within natural environments. What changed was not the brain, but the world surrounding it. In the relatively short span of recent history, humans reshaped their environments in ways that previous generations could never have imagined. Artificial lighting softened the arrival of night. Machines filled the air with constant mechanical sound. Digital networks began delivering information faster than any natural signal ever could. These changes allowed human societies to grow, travel farther, and communicate across great distances. Yet they also transformed the sensory landscape in which human perception operates. The quiet patterns that once guided awareness now appear less frequently in everyday life. As a result, the abilities that evolved to interpret those patterns may seem rare or unusual when they appear. But rarity in modern environments does not mean absence in the human mind. Beneath the surface of modern attention, the ancient architecture of perception remains present. The ears still detect faint variations in sound. The eyes still recognize small movements across distance. The brain still compares the present moment with patterns stored in memory. When the environment becomes quiet enough and familiar enough, these systems can begin working in the same gentle way they once did throughout most of human history. A person walking slowly through a forest path, listening to the wind and distant animals, may notice that awareness begins to widen. The mind becomes less occupied with rapid signals and more attentive to the rhythm of the landscape. In such moments, the boundary between past and present becomes surprisingly thin. The same nervous system that guided early humans across open land still exists within the modern mind. Perhaps the ancient ability described in the title has never truly disappeared. Perhaps it has simply been waiting, quietly, beneath the surface of our busy world. And if that is true, an even more curious question may remain. If the human brain still carries this ancient sensitivity, how many people might rediscover it if they once again spent enough time listening carefully to the quiet patterns of the world around them?